Hello there and welcome to Life Beyond Seen, where curiosity gets comfortable and science slows down enough for the mind to loosen its grip a little. Tonight, we are turning our attention to a creature so large that it can feel slightly unreasonable. Not dangerous in the way a shark is dangerous, not dramatic in the way a volcano is dramatic, but unreasonable in the simple sense that it seems to ignore the usual rules about how big an animal ought to be. The blue whale is not merely large. It is the kind of large that makes familiar comparisons start to wobble. It is the kind of large that makes a school bus seem manageable, an elephant seem compact, and your own body feel like a very modest project indeed. And yet this colossal animal lives not in a fantasy world, not in prehistory, not in the imagination of sailors who have had too much sun, but here on Earth, in the same oceans that lap quietly against beaches where people lose flip-flops and argue about sunscreen. Before we settle into the size of this astonishing animal, I would love to know where you are listening from tonight. Are you under a blanket with the window cracked open a little? Are you listening with the lights off, hoping your brain will finally stop replaying things it should have let go of hours ago? Is it late where you are, or has your day only just begun? It feels fitting somehow, talking about the biggest animal on the planet while each of us listens from our own small corner of it. Some of you may be close to the sea, some may be hundreds or thousands of miles from salt water, and still somewhere out there, in a part of the ocean no road can reach, a blue whale may be moving through the dark like a living continent with a pulse. If this gentle expedition turns out to be a soothing one, or if it gives your thoughts something calm and interesting to follow while the rest of you winds down, I would be very grateful if you liked the video, subscribed, and perhaps shared it with someone else who enjoys drifting off with a question that starts out simple and becomes pleasantly more complicated the longer you sit with it. Because at first glance, how big is the blue whale really? Sounds like one of those questions with a quick answer. Very big. Extremely big. Bigger than you think. Job done. Kettle on. But the moment you begin to answer it properly, you realise that size is rarely just a number. It is also a matter of scale, context, surprise, and the limitations of the human imagination, which is quite good at inventing problems and somewhat less good at picturing 90 or 100 feet of animal gliding beneath the surface of the sea. That really is where the trouble begins. Most of us know, at least in a general way, that the blue whale is the largest animal alive today. Many people also know that it is the largest animal known to have ever lived. And those are impressive facts, but they're also a little too tidy. They sit there like labels on a museum card. Largest animal. Yes, very good. Move along. But a statement like that does not immediately land in the mind with the force it deserves. We hear it, we nod, and then we go back to thinking in ordinary human sizes. A tall person, a big dog, a large car, a room with decent storage. The brain likes familiar categories. It likes things that can fit into a glance. The blue whale does not fit into a glance. It barely fits into common sense. Part of the problem is that human beings are not built to understand extreme scale very well. We handle the middle ground quite nicely. We know what a loaf of bread looks like. We know how long a sofa is, roughly how much a suitcase weighs, roughly how large a horse is when it stands too close and reminds you that it is in fact a lot of horse. But once things become very small or very large, the mind starts cheating. It rounds, it shrugs, it says, "That is enormous," and then quietly stops doing the work. A blue whale is one of those animals that causes the mind to give up early, like a student who sees the exam paper, looks out the window, and decides to become a shepherd instead. So tonight, instead of settling for enormous, we're going to take our time with it. We're going to look at what that size means in actual terms, in bodily terms, in comparisons that belong to the world we know. We're going to ask not only how long a blue whale can be, but what that length feels like when translated into streets, rooms, vehicles, and the size of things we use every day without ever once expecting them to be useful in understanding a marine mammal. We're going to consider its weight, because length alone is only part of the picture. A creature can be long and still not feel truly massive. The blue whale manages both. It is long in the way that gives you time to notice that it is still going, and heavy in the way that makes numbers feel slightly nervous. It also helps to remember that the blue whale did not get this big just to impress us, though if that were the goal, it would be succeeding spectacularly. It grew into this size because the ocean allows for a kind of body plan that land simply does not. On land, gravity is bossy. It insists on being noticed. It presses down on bones and joints and muscles and makes size expensive. The sea, by contrast, offers support. It lifts, it carries, it changes the rules. And so the blue whale exists as proof that when an environment makes room for enormity, life will sometimes take that invitation and go much further with it than anyone expected. The result is an animal whose dimensions can sound exaggerated even when they are not. This is one reason people so often reach for comparisons. You may have heard that a blue whale's heart is as big as a small car, or that its tongue can weigh as much as an elephant, or that a human could crawl through some of its major blood vessels, though that last image has always struck me as the sort of fact that is technically memorable, but not necessarily one anyone needed while trying to relax. Comparisons help because the raw numbers can be slippery. 30 meters, 150 tons. These are meaningful measurements, but they are not intimate ones. Most of us do not live our lives in tons and meters. We live them in doorways, staircases, cars that refuse to start in winter, shopping bags that dig into our fingers, and beds that somehow feel too small when the fitted sheet comes loose. To understand the blue whale properly, we need to bring it into that human frame of reference without shrinking its strangeness. And there is something genuinely strange about the blue whale, not monstrous strange, not eerie. Simply strange in the way all truly enormous living things are strange. It breathes air like we do. It is a mammal like we are. It nurses its young. It is warm-blooded. It must rise to the surface to breathe. In some ways, it is not alien at all. And yet, the scale changes everything. A whale calf can be larger at birth than many fully grown animals ever become. Its daily feeding needs are so vast that even trying to picture them turns into a logistical exercise. Its calls can travel over great distances underwater. Its movements span oceans. It belongs to the same broad biological club as mice, dogs and people, which is a bit like saying a cathedral and a garden shed are both buildings. True, but not exactly the whole story. There is also a psychological effect that comes with animals this large. They begin to take on a kind of mythic weight in the mind, not because they are mythical, but because they feel like they should be. The blue whale sounds like the answer to a child's question designed to trap an adult. What is the biggest animal ever? Bigger than dinosaurs? Bigger than elephants? Bigger than every shark? Yes. Yes. Apparently. And not only bigger but alive right now, moving through modern oceans beneath satellites, cargo ships, fishing vessels, and waterproof action cameras. There is something almost rude about it. Humanity has spent a great deal of time acting as though it is the central character in every scene. And then along comes the blue whale, minding its own business, outweighing the storyline. What makes this even more interesting is that the blue whale's size is not loud in the way we often imagine bigness to be. On land, large animals tend to announce themselves. An elephant snaps branches. A rhinoceros looks like it was built by someone who distrusted corners. Even a moose has the decency to seem improbable in a way that warns you immediately. But the blue whale lives in water, where mass becomes smoother. It does not stomp into view. It emerges. It surfaces. A stretch of dark back breaks the water. A blow rises into the air, and for a brief moment one of the largest beings ever produced by life on Earth appears and disappears again with remarkable calm. There is no theatrical roar, no jungle drums, just breath, body, and sea. If anything, the restraint makes it more impressive. Another reason the true size of the blue whale is hard to appreciate is that almost nobody sees one properly. Not really. Even people who go whale watching often see only part of the animal at a time, a back, a dorsal fin which on a blue whale is surprisingly small considering the rest of the situation, the lift of the tail sometimes, a shape beneath the surface. Rarely do you get the full clean outline of the whole animal at once in a way that allows the mind to take a proper measurement. Imagine trying to understand the size of a train while only ever seeing one carriage at a time disappearing into fog. You would know it was long, certainly, but the full scale would remain frustratingly just out of reach. The ocean is good at this. It conceals the edges of things. Even photographs can be deceptive. Without a clear point of comparison, a blue whale in open water can look oddly manageable. The sea itself is such a vast background that almost anything placed against it can seem smaller than it is. Put a blue whale in the middle of the ocean, and your brain, lacking helpful furniture and offended by the lack of sidewalks, may quietly underestimate the whole affair. Put that same whale next to a boat, and suddenly the scale begins to land. Put it next to divers and it lands harder. Put it beside things from daily life, and then the mind starts to adjust in earnest. This, I suspect, is why people keep inventing comparison after comparison, not because the numbers are unclear, but because the imagination needs repeated assistance. So when we ask how big the blue whale really is, we're not only asking for a biological measurement, we're asking for translation. We're asking to convert ocean scale into human scale without losing accuracy. We're asking the mind to hold something so large that it exists at the edge of ordinary intuition. That means we will need patience, we will need examples, we will need a willingness to let the answer become more impressive the longer it goes on, which is one of the blue whale's special talents. Almost every fact about it begins in amazement and then keeps climbing. It is large, then it is larger than that, then larger still. Once you think about the parts of it, the weight of it, the amount it must eat, the size of its newborn, the effort required to measure it, the simple practical challenge of being that much living matter and somehow making the whole arrangement function, there is also a quiet lesson in beginning with a creature like this. The natural world is full of animals we know by name but not by scale. We think we know them because we have seen illustrations, logos, documentaries, museum models, or toy versions that can be held in one hand. The blue whale suffers especially from this. It has been turned into icons, diagrams, and educational side notes so often that its reality can begin to feel flattened. We end up knowing that it is the biggest without actually feeling what biggest means. And there is a difference between the two. One is trivia, the other is perspective. Perspective is the thing that makes you sit a little more quietly after the fact. If you are somehow able to stand beside a blue whale in full impossible safety and see it all at once, I suspect the reaction would not be elegant. It would not be a sophisticated scientific murmur. It would be something much simpler. Something along the lines of, "Oh, right, that is ridiculous." Because it is ridiculous, in the best and most factual sense. The blue whale is so large that it changes the emotional temperature of numbers. 30 meters stops feeling like a line on paper and becomes a physical statement. 100 plus tons stops sounding like a shipping problem and starts sounding like a miracle of anatomy and ecology and evolution, all working together in a way that, frankly, seems a bit showy. And yet the blue whale did not arrive at this size overnight, nor did our understanding of it. Measuring these animals has never been simple. Early estimates were often rough. Bodies seen at sea are not easy to gauge accurately. Even stranded whales can be difficult to measure cleanly because of posture, curvature, and the simple awkwardness of trying to take a tape measure to something that resembles a submarine with lungs. Scientists have refined these measurements over time using better methods, better tools, aerial imaging, and more careful comparisons. So part of the story ahead is not just the whale's size itself, but how we learn to describe it with confidence. Because once an animal becomes large enough, even certainty has to work a little harder. For now, it is enough to settle into the fact that the blue whale is not merely a large version of a familiar animal. It is a scale event. It is one of those living beings that forces language to stretch. You can say largest, longest, heaviest, but eventually you reach the limits of adjectives and must begin building scenes instead. A whale longer than this, heavier than that, with parts that each sound like exaggerations until you check them and discover that, annoyingly for your sense of proportion, they are broadly true. And that is where we're going next, because before the question can be answered properly, we need to start with the first thing most people try to picture, which is length, and why even when you know the number, the actual impression of it still manages to arrive a moment later. There is something oddly difficult about meeting the idea of a blue whale for the first time in any serious way, because the mind tends to greet it with a polite sort of disbelief. Not open disbelief, not the kind that says, "No, that cannot be true," but the quieter kind that nods along while secretly refusing to picture the full thing. Yes, the largest animal on Earth. Very impressive. And then the brain, being a practical little creature, files that information away in the same drawer as longest bridge, tallest tree, deepest cave, and other facts that sound grand but do not always settle into the body as something real. The trouble with the blue whale is that it resists that sort of tidy filing. The more closely you try to imagine it, the more it begins to feel like something borrowed from myth and left behind in modern oceans by administrative error. Part of this is because truly extreme size has a strange effect on human perception. We're quite comfortable with big things up to a point. A horse is big. A car is big enough to feel substantial when it rolls too close past a puddle and ruins your morning. A bus is big. A small house is big. An elephant is very big, especially when you stop thinking of it as an animal from a documentary and start thinking of it as several tons of opinion on legs. But somewhere beyond that, ordinary categories begin to fail. Things stop feeling merely large and start feeling improbable. They no longer fit easily into the mental shelf where we keep all the objects and creatures we know how to size at a glance. The blue whale lives well beyond that shelf. It does not just overflow it. It makes the shelf itself seem like a very optimistic attempt. There is also the fact that most of us meet blue whales first as words, not as bodies. We hear about them in school, or see them in documentaries, or encounter them in books where they are described with respectful amazement and the occasional comparison involving buses. We learn that they are enormous, that they are mammals, that they breathe air, that they feed on creatures so small and so numerous that the whole arrangement seems like a joke biology is telling itself. But these are all pieces of information, and information is not always the same as impression. You can know a thing perfectly well on paper and still fail to feel its reality. This happens with large numbers, deep time, and international shipping costs. It also happens with blue whales. The first real impression often comes when a comparison finally lands, not an abstract one, but the sort that attaches itself firmly to the furniture of the world. A blue whale is not just large. It is so large that the normal cues we use to judge animals begin to malfunction. Most animals have a shape that the mind can instantly understand. Dog-sized, horse-sized, person-sized, cow-sized. Even if we do not know the exact measurements, we know what category of bigness we are dealing with. A blue whale has no category that belongs to ordinary life. It does not resemble a large version of something you might pass in a field or at a zoo. It resembles a stretch of living landscape, a moving structure, a body so extended and so heavy that when pictured clearly it gives the strange impression that it ought to have streets on top. This is one reason it feels almost unreal. Not because it is hidden, though that does not help, but because it exceeds the habits of the mind. Human beings are decent at estimating objects we can approach, circle and compare with our own bodies. We know what it means to stand next to a bicycle, a piano, a car, a wardrobe. We know what it means to lift a suitcase and regret our choices. We understand scale best when it meets us at ground level, at walking level, at the level of door frames and steps and ceilings. A blue whale lives outside that cozy zone of comparison. It belongs to the open sea, which is one of the least helpful environments imaginable if your goal is to understand size properly. The ocean gives you almost nothing to work with. No trees nearby, no buildings, no roads, no parked hatchback to say, "Ah, I see. This animal is roughly 6 hatchbacks long, and therefore I should sit down." Instead, what you usually get is a glimpse, a back, a blow, a curved stretch of dark grey-blue skin breaking the water and then disappearing again. Perhaps a tail rising at the end of a dive, perhaps a dorsal fin, tiny-looking relative to everything else, which only adds to the confusion because it seems almost too small for an animal of that scale. Like a decorative afterthought someone added late in the design process. You do not see the whole whale laid out neatly from snout to tail, the way you might see a bus parked in a lot, or a crocodile sunning itself on a riverbank. You see portions, transitions, hints, and the mind is left to assemble the rest. The mind, unfortunately, is not always equal to the task. There is something else at work too, and it has to do with movement. Large animals on land usually move in ways that emphasize their weight. They shake the ground, they strain branches, they make an event of crossing from one place to another. Even when they move gracefully, you still sense the effort behind the grace. Gravity is present in every step. It reminds you what mass means. But in the ocean, that relationship changes. Water softens the obviousness of weight. It carries it. It allows enormous bodies to move with a smoothness that can seem almost deceptive. A blue whale does not lumber. It does not stomp. It glides. It passes through the sea with a kind of composure that makes its size harder to process, because we are used to associating great mass with noise and strain and visible exertion. The blue whale can be immense and still appear calm enough to insult every treadmill in the world. That calmness matters. If the blue whale behaved like a creature desperate to prove its own dimensions, perhaps it would be easier to believe in immediately. If it thrashed constantly, shattered the surface, roared like a machine with feelings, or left craters wherever it rested, then our minds would quickly catch up. But it does none of that. It surfaces, breathes, and disappears. It carries on with the business of being astonishing as if astonishment were entirely somebody else's administrative burden. This quietness gives the animal a strange authority. It does not ask to be noticed. It simply is what it is. And that makes the impression stronger when it finally lands. The blue whale does not sell its size. It leaves you to discover it for yourself, and that process is much more unsettling in the best possible way. There is also the matter of familiarity. The blue whale is not some reptilian relic with armour plates and teeth like serving utensils. It is not obviously monstrous. It is a mammal. That alone creates a certain bridge between us and it. Mammals feel, on some level, understandable. They breathe air. They feed their young with milk. They are warm-blooded. Their bodies belong to the same broad biological neighbourhood as ours, even when the neighbours have taken their renovations quite a long way. A blue whale is not alien in the way a jellyfish can feel alien. It is recognisable. There is a face there, an eye, a mouth, lungs, a heartbeat, a calf beside its mother. And perhaps that is part of what makes the scale so difficult to accept. The animal is both familiar and wildly beyond familiar at the same time. It shares enough with us to feel biologically close, but in dimensions that make that closeness faintly absurd. This tension between familiarity and impossibility gives the blue whale much of its almost unreal quality. It is not only that it is large, it is that it is large while still being an animal we can relate to in basic ways. If the largest creature on Earth were some giant colonial organism spread over a reef, or a sprawling jelly of dubious intention, perhaps the mind would shrug and say, well, the sea is strange. But the blue whale feels closer than that. It is a mammal scaled up to a degree that seems rude. It makes you realise that the mammal template, that warm-blooded, air-breathing, live-bearing design, can be stretched much further than the average person ever needed to know, and once you know that, it changes the mental map slightly. It is as if someone has shown you that your house cat and a cathedral both operate under the same general principles of shelter. Technically true, psychologically unhelpful. Children often grasp the emotional truth of this faster than adults do. Adults tend to become trapped by the dryness of facts. They hear the largest animal ever known to have lived and immediately start categorizing. Largest among whales, largest among living animals, largest by weight, presumably. One begins to hear filing cabinets opening. Children, on the other hand, often skip straight to the useful response, which is open astonishment. Bigger than dinosaurs, bigger than elephants, bigger than all the sharks, and suddenly the scale is felt rather than merely understood. This is one of the few cases where a child's instinctive reaction is also the correct scientific mood. The blue whale deserves astonishment. It deserves the pause that comes after a fact too large to sit quietly in the mind. Photographs do not always help. In some cases, they make matters worse. A whale photographed at the surface in open water can look oddly manageable, as though it were merely a large fish with good publicity. Without context, the eye has very little to work with. Water is not helpful that way. It does not offer familiar edges. It does not offer paving stones, fence posts, lamp posts, or a person standing beside the thing with an expression of responsible alarm. Sometimes a blue whale in a photograph looks less overwhelming than a moose beside a car, simply because the moose and the car exist in a world our brains know how to measure. Put a whale next to a research boat, however, and the story changes. Suddenly the animal stops being an elegant shape in abstract blue and becomes a problem for the imagination in the most literal sense. It is not that the whale grows, it is that our understanding does. Even then, the scale arrives in stages. First comes the recognition that it is long. Then comes the slower recognition that it is not just long, but deeply massive throughout much of that length. A snake can be long, a train can be long, a hallway in an underfunded building can be long in a way that slightly weakens the spirit. Length alone is not enough. The blue whale has length with volume, breadth, depth, substance. It is not a narrow ribbon of animal. It is a vast, muscular, blubber-insulated body shaped by the demands of migration, feeding, diving, and life in cold oceanic waters. That is a more difficult thing to imagine. The mind can often cope with length by simplifying it into a line. It cannot do that so easily with the blue whale, because the width and fullness of the body keep interrupting any attempt to flatten it into a neat visual idea. Then there is the issue of sound, or rather, the lack of the sort of sound we expect from something that size. If you imagine a very large animal on land, you often imagine noise to match. Footsteps, crashing branches, warning calls, the general administrative racket of great mass interacting with the environment. But the blue whale lives in a medium where much of its drama is hidden from our ears. Underwater, it is a world of pressure and resonance and long-travelling calls, but from the perspective of a person in a boat, the moment of encounter can be surprisingly restrained. A blast of exhaled air? Yes. The slick sound of water sheeting off skin, the rise and fall of a huge back. Then stillness again. A creature that large feels almost unreal, partly because it is not announcing itself in the blunt human register of bangs, stomps and crashes. It is writing its presence in a different language, and because most people never stand anywhere near a complete blue whale body, the imagination remains in charge for longer than usual. That can be a wonderful thing, but it can also be a misleading thing. The imagination is quite happy to substitute symbols for realities. Blue whale, biggest animal, ocean giant. It puts a noble silhouette in the mind, perhaps a bit of sea spray, and congratulates itself on a job well done. But the real physicality of the animal is heavier, stranger, and more specific than that. The skin is mottled, the head is broad and U-shaped, the body tapers in a way that still must contain astonishing systems of muscle, blood, lungs, and bone. The small dorsal fin sits far back on the body. The sheer area of the back alone is enough to make a person reconsider what counts as a back. These details matter because unreality often survives in vagueness. The more specific the whale becomes, the more solidly it enters the mind. At the same time, specificity can deepen the sense of unreality rather than dissolve it. This is one of the blue whale's more unfair talents. Learn that it is the biggest animal known ever to have lived, and that sounds impressive. Learn that it can grow longer than many city buses and outweigh multiple elephants combined, and it becomes more impressive. Learn that this same animal feeds primarily on swarms of small crustaceans called krill, opening a vast mouth to engulf enormous quantities of seawater before filtering out its tiny prey, and now it feels not just large but conceptually mischievous. There is something delightfully unreasonable about an animal of such scale relying on prey so small. It is as though the largest creature on Earth runs on spoonfuls. Not literally, of course, but close enough to feel like a joke nature told with a completely straight face. That feeding strategy contributes to the dreamlike impression too. We're used to a certain narrative. Big predator, big prey, large jaws, dramatic chase, a meal with some theatricality to it. The blue whale ignores that script. It is enormous, and yet it feeds on krill. It takes the smallest practical option, and simply commits to volume on an almost unbelievable scale. That contradiction between the hugeness of the animal and the smallness of its food makes the whole creature feel even more peculiar. It is not merely big, it is big in a way that refuses the tidy expectations we might have built around size. The mind reaches for a more dramatic story, and the blue whale, with immense dignity, continues filtering tiny crustaceans through plates of baleen as if the rest of us are overcomplicating things. There is another subtle reason the blue whale feels unreal, and it has to do with rarity of encounter. However famous the species may be, a blue whale is not part of everyday human life. We do not pass them on roads. We do not hear them from our gardens. Even in places where they migrate, seeing one can be an event requiring patience, luck, and time on the water. Rarity adds a kind of distance to reality. Common things become solid in the mind because we meet them repeatedly. We know the size of pigeons because pigeons have made it their business to become impossible to ignore. We know the size of cows because fields have been kind enough to put cows on display for centuries. But blue whales remain mostly out of sight, moving through expanses too large for casual acquaintance. The hidden life of the animal allows unreality to cling to it longer. All of this combines into that first true impression people often report when they encounter the scale of a blue whale properly. It is not just amazement, it is a sort of recalibration. A dawning realization that the living world includes dimensions we do not naturally carry around in our day-to-day picture of it. The blue whale reminds us that life is not arranged to fit our instincts for proportion. The oceans, in particular, are under no obligation to remain within comfortable human visual limits. They have room for creatures that make school buses feel like handy examples, and elephants feel like useful units. They have room for animals so large that even now, in an age of satellite images and drone footage and searchable databases, we can still struggle to picture them cleanly on the first attempt. And perhaps that is part of the pleasure of thinking about a blue whale carefully. It interrupts the stale edges of familiar thinking. It takes a phrase like largest animal and forces it out of the realm of trivia and back into the realm of actual wonder. Not the loud, frantic kind, the quieter kind, the kind that slows you down for a moment, the kind that makes you picture the open ocean differently, not as empty water between places, but as an inhabited space still capable of holding bodies that stretch the imagination almost to snapping point. Once that first impression settles properly, the whale stops feeling like a fact and starts feeling like a reality. A very large, very breathing, very specific reality. And once that has happened, the next difficulty arrives almost immediately, because after the first impression comes the natural attempt to pin it down more precisely. It is one thing to feel that a blue whale is enormous. It is another to ask how long that enormity actually is from the tip of the rostrum to the tail, and why the number, when it finally appears, still takes a moment to do its work. When people first ask how long a blue whale is, they usually expect a number to settle the matter. Something clean, perhaps reassuringly definite. 30 metres, 100 feet. There we are, mystery solved, put the kettle on, everyone back to normal proportions. But the odd thing about the blue whale is that the number does not settle the matter at all. It only opens the door. According to NOAA Fisheries, blue whales can reach up to 110 feet in length, and NOAA's outreach material gives the familiar rounded version as about 31 metres or 100 feet, roughly the length of a basketball court. Smithsonian Ocean likewise describes blue whales as reaching about 100 feet or around 30 metres. Those are straightforward measurements, and yet they still land in the mind like a fact the imagination has signed for without reading properly. The first difficulty is that 100 feet is not a size most people ever truly meet in one uninterrupted object. We know 10 feet. We know 20 if we have stood in a modest room and thought, yes, that seems about right. We can handle the length of a car, a sofa, a bed, a table, perhaps even the rough dimensions of a small apartment if we have recently tried to fit furniture into one and learned things about ourselves. But 100 feet as a single living body is another matter. It is not simply large, it is long enough that the eye wants checkpoints. A beginning, a middle, a place where the creature ought to have the decency to stop. The blue whale declines, it keeps going. That is one of the reasons the length feels unreal even after you know it. Your mind measures the front portion, assumes the rest will sort itself out, and then discovers with quiet alarm that there is still more whale. Even the tidy rounded figure of 100 feet can be a little misleading, because blue whales are not all built to exactly one grand design, stamped out by a cosmic manufacturer with a clipboard and a measuring tape. Length varies by subspecies, region, sex, and individual. NOAA Fisheries notes that Antarctic blue whales are generally larger than other blue whale subspecies. In the North Atlantic and North Pacific, blue whales can grow to about 90 feet, while Antarctic individuals can reach up to about 110 feet. NOAA's 2018 Blue Whale Recovery Plan says adults can reach 32.6 metres, but that blue whales in the North Atlantic and North Pacific are generally smaller, with maximum body length there of approximately 27 metres. The same recovery plan notes that pygmy blue whales may reach only about 21 metres when mature, which is still a remarkable sentence because only is doing some very heavy lifting there. It also notes that females are slightly larger than males, as is true in other baleen whales. That variation matters because people often picture the blue whale as though it were a single fixed length, the way one imagines a ruler or a standard piano. But living things rarely behave so conveniently. Asking how long a blue whale is can be a bit like asking how tall a tree is. You can answer in a broad way, but the true answer depends on which tree, where it grew, how old it is, and whether the universe was feeling especially ambitious that year. A mature northern blue whale and a truly immense Antarctic blue whale do not make the same visual statement, even though both are absolutely, categorically more whale than the average mind wished to process before bed. The important point is not that every blue whale reaches the upper extreme, but that the species as a whole operates in a length range that already sits far beyond ordinary animal scale. And this is where the comparisons begin to earn their keep. A basketball court is useful because most people have at least some idea of its length, even if their personal relationship with basketball ended years ago with a missed shot and a brief lesson in public humility. NOAA's outreach material says a blue whale can grow to roughly the length of a basketball court, and that comparison works because it finally gives the number a floor to stand on. Picture the court, the painted lines, the hoops at either end, the scuffed wood, perhaps the squeak of shoes if your memory insists on being cinematic. Now, replace the entire playing surface with one animal. Not a serpent-like thread of animal, but a thick-bodied, warm-blooded, air-breathing mammal. Suddenly the question is no longer what is the number, but how is that allowed? The sea, unfortunately, is not a very helpful place for appreciating that length at first glance. On land, a 100-foot object would have the courtesy to stand beside buildings, roads, parked vehicles and alarmed people. In the ocean, scale becomes slippery. You may see only part of the whale at a time. A back rises. A blow hangs in the air. The body arches. Then the animal slips forward and down again, and because the water hides the lower outline and conceals the full body, the eye often underestimates what it has seen. NOAA describes blue whales as having long bodies and a generally slender shape, and that slenderness can be deceptive. Long and slender sounds almost manageable until you remember that the long in question may be 90 to 110 feet. A thing can be graceful and still be so large that your brain requires a second pass. Another reason the length is hard to feel properly is that a blue whale is not built with dramatic interruptions. There are no towering antlers, no absurd sail on the back, no great set of projecting horns to help the eye break up the figure into memorable landmarks. The body runs in one long continuous hydrodynamic sweep. Noah describes a long body, a broad flat rostrum when viewed from above, and a proportionally smaller dorsal fin compared with other baleen whales. That smaller dorsal fin, set far back, can actually make the whale seem shorter at first, because our eyes are used to using such features as markers. On a blue whale, the marker comes late and modestly, as if the whale were in no rush to help us understand it. The result is that the front half alone can look like a complete large animal, right up until you realise there is an enormous amount of body still to come. It is also worth noticing that length and size do not always mean the same thing in the human imagination. A long rope is long, a long corridor is long. A blue whale is long in a way that cannot be separated from the fact that it is also a vast, muscular, heavy-bodied creature. Even when we focus only on length, the number carries more force because the whole body has substance from end to end. Noah notes that even North Atlantic and North Pacific blue whales, which are generally smaller than Antarctic individuals, are over 100,000 pounds, while Antarctic whales can exceed 330,000 pounds. So when you picture 90 or 100 or 110 feet, you are not picturing a narrow line drawn through the sea. You are picturing a length inhabited by enormous volume that makes the distance feel different. It is the difference between picturing a hallway and picturing a hallway made entirely of mammal. There is a curious mental exercise that helps here, and it has less to do with mathematics than with patience. Instead of trying to imagine the whole whale all at once, imagine your eye travelling along it. Start at the rostrum, the front of the head, smooth and broad. Move past the blowholes. Follow the immense back, keep going a bit longer. Notice the dorsal fin arriving much later than expected. Continue toward the narrowing body, and then the tailstock and the flukes. That slow internal tracking is often more effective than tossing a number into the dark and hoping it sticks. NOAA's descriptions of the animal's body plan help with this, because they turn the whale from an abstract giant into a sequence of real anatomical regions. And once it becomes a sequence rather than a symbol, the length starts to feel heavier in the mind. It ceases to be a fun fact and becomes a spatial problem. The comparisons with other whales help too, not because the blue whale needs the validation, but because contrast clarifies. Smithsonian Ocean Size Chart places the blue whale at about 100 feet, while grey whales reach around 49 feet and orcas around 31 feet. NOAA's Whale Outreach page notes that fin whales, the second largest whales, can grow to about 88 feet. That means the blue whale is not merely first by a technical margin, it stands at the upper end of a size ladder where even the runners-up are already enormous by any normal standard. When the second largest whale can approach 88 feet and still be introduced as a supporting character in a conversation about the blue whale, you begin to understand how distorted the scale has become. The blue whale does not just win, it alters the emotional meaning of the contest. Then there is the question of growth, because a 100-foot animal does not arrive at that length by magic. The NOAA recovery plan notes that blue whale calves can be about 8 meters long at birth, which is already enough to make many full-grown land animals look as though they have been working with unnecessarily limited ambitions. That fact belongs more properly to the later story of calves and early growth, but it is relevant here because it reminds us that blue whale length is not only an adult curiosity, it is a life history written on an oversized scale from the beginning. The species starts large, grows larger, and then, in some individuals, and especially in Antarctic blue whales, keeps going until the final figure sounds less like zoology and more like someone misread the blueprint. What makes the length feel most astonishing, though, is not simply the top measurement. It is the persistence of that measurement in a real, functioning, living body. This is not an inflatable parade object wobbling down a street in mild danger of drifting into a lamppost. It is an animal that migrates, dives, feeds, communicates, reproduces, and navigates oceans while carrying this extraordinary length with complete biological seriousness. NOAA notes that blue whales are found in all oceans except the Arctic, and that they migrate seasonally between feeding and breeding areas, with some making lengthy journeys. The long body is therefore not some decorative excess. It is part of a working design, one refined by evolution for life in the open ocean. And perhaps that is the most impressive part of all. The length is not a gimmick, it is a solution. An extravagant one certainly, but a real one. Human beings are often tempted to think of size as a spectacle first and a practical matter second. We see the large and assume it exists to amaze. But in nature, immense size usually has reasons behind it, even when those reasons leave us staring at the horizon with the expression of someone who has just realised the furniture catalogue was not to scale. The blue whale's length makes sense in the environment that shaped it. Water supports weight. Long, streamlined bodies move efficiently through it. Vast feeding opportunities, especially dense krill patches, reward animals that can travel, engulf and process huge amounts of prey-laden water. The length is therefore tied to the whole life of the whale, not just its reputation, which means the correct reaction to 100 feet is not only amazement, but a kind of respect for the engineering involved. It is one thing to be large, it is another to be long on purpose. And even now, after the measurements, after the comparisons, after the correction that northern animals are generally smaller and Antarctic animals larger, after the basketball court and the reminder that the body is long in one uninterrupted living sweep, the mind still tends to lag half a step behind. That may be unavoidable. Some scales are not meant to fit neatly inside ordinary intuition. They must be approached from several angles before they begin to hold. So if the number still feels slippery, that is not a failure. That is just your imagination doing what imaginations do when confronted with something built on the far side of everyday proportion. It catches up in stages. First the number, then the outline, then the long dark body surfacing and continuing until the final impression arrives with proper force. This is not just a big whale. This is length stretched to the edge of what a mammal can make practical in the ocean. And once that length has started to feel real, another question pushes forward almost immediately, because a body can be astonishingly long and still not tell you the full story. A blue whale is not impressive only because it covers distance from snout to tail. It is impressive because all the length is filled with extraordinary mass, which means the next thing we have to face is not how far the whale goes, but how much whale there is once you add gravity back into the conversation. The moment people move from asking how long a blue whale is to asking what it weighs, the whole animal changes in the mind. Length is impressive, certainly. A 100-foot body already feels like a prank played on common sense. But weight is different. Weight drags the conversation out of abstraction and back into gravity. It reminds you that this is not merely a long shape sliding elegantly through the water. It is an enormous quantity of living matter. According to NOAA Fisheries, blue whales can weigh up to 330,000 pounds, and NOAA's recovery plan describes adults as reaching more than 150,000 kilograms. National Geographic Education gives the familiar rounded version as much as 200 tons, or 181 metric tons. However you phrase it, you're no longer dealing with a big animal. You're dealing with a body so massive that ordinary adjectives begin to look underqualified. What makes that number especially slippery is that most of us have almost no experience with a single living creature weighing anything close to that. We know what a person weighs, roughly. We may know what a large dog weighs, what a horse weighs, what a car weighs. If we have ever had to fill out the sort of rental paperwork that makes one briefly suspicious of all joy. A blue whale, by contrast, weighs in a range usually reserved for industrial equipment, loaded vehicles and engineering problems that require men in hard hats to speak in grave, practical tones. National Geographic Education says a blue whale can weigh about the same as 15 school buses, while Monterey Bay Aquarium uses another helpful comparison, saying a blue whale can weigh as much as 30 elephants. Those are the sort of comparisons the brain needs, because otherwise 330,000 pounds simply sits there like an offended spreadsheet. Even then, the mind still lags behind a little, because it is one thing to hear 15 school buses, and another to feel that weight is belonging to one animal with skin, blood, lungs, a heartbeat, and the daily expectation of functioning normally. A convoy of buses is clearly a large amount of matter. 30 elephants is also a large amount of matter, and more importantly, it is a large amount of matter that tends to look very determined about its own existence. But the blue whale gathers that mass into one continuous body, and then moves it with enough ease that the sea almost conceals the insult. On land, a creature weighing that much would be a catastrophe of logistics. In the ocean, it is somehow streamlined. That contrast is one of the reasons blue whale weight feels almost absurd at first contact. It also helps to understand that what does a blue whale weigh is not quite as simple a question as it sounds, because not every blue whale weighs the same, and published public-facing figures often emphasise slightly different parts of the range. NOA notes that Antarctic blue whales are generally larger than other blue whale subspecies. In the North Atlantic and North Pacific, blue whales can grow to about 90 feet and are over 100,000 pounds, while Antarctic animals can reach about 110 feet and weigh more than 330,000 pounds. NOAA's recovery plan likewise says blue whales in the Northern Hemisphere are generally smaller than those in the Southern Ocean. So the answer depends partly on which blue whale you have in mind. A fully grown northern animal is already enormous. An Antarctic giant pushes the whole matter even further into the realm of surely that cannot be the final number. That variation is important because people sometimes speak as if there were one official blue whale, perhaps hanging in some celestial filing cabinet under largest. Real animals are not so obliging, sex matters too. NOAA notes that female blue whales are generally larger than males, as is true for many baleen whales. So even within one region and one subspecies, weight is not a fixed figure but a living range shaped by age, sex, population and condition. This is one reason the largest public numbers are best heard as upper-end landmarks rather than something every adult carries around as standard equipment. The core truth remains stable though, and it is dramatic enough without embellishment. A blue whale is not just the largest animal alive. It is carrying more body mass than almost any comparison the average person uses in daily life. The difficulty gets even better, or worse, depending on your relationship with numbers, when you realise that whale weight is not something scientists can settle by rolling the animal onto a giant scale and waiting for the display to stop blinking. Woods Hole. Oceanographic Institution explains this rather plainly. Scientists cannot exactly put these large marine mammals on a scale. Historically, much of the body mass data for whales came from weighing dead or stranded individuals, or from samples originating in whaling operations and bycatch. WHO. I note that this older approach had real limitations, including distortions in carcasses caused by bloating and deflation. In other words, the exact weight of a blue whale is not merely a large fact. It is a large fact that has to be worked for. That challenge is worth lingering on for a moment, because it explains why blue whale weight can feel a bit fuzzier in public conversation than length. Length can often be estimated from photographs, aerial imagery, and known scaling references with reasonable confidence. Weight is trickier because it depends on volume, condition, stored energy, feeding state, and the small inconvenience that the subject is a gigantic marine mammal mostly found in open water. WHOI reports that researchers developed a method using drone images to measure body length, width and height, and then calculate volume and mass for free-living whales. That was a significant step because body mass is central to understanding whale growth, energy requirements and reproduction. So when we speak of a blue whale's weight, we are not just reciting a dramatic number. We are touching a measurement that science has had to approach with some ingenuity and a great deal of patience. And perhaps that is fitting, because the blue whale's body mass is not merely impressive trivia. It is biologically active. It has to be maintained, insulated, powered and moved. NOAA notes that blue whales feed almost exclusively on krill, and that some of the biggest individuals may eat up to 6 tons of krill a day. That sentence sounds unreasonable the first time you hear it, but then the weight of the whale reminds you that unreasonable is exactly the point. A body that can exceed 330,000 pounds is not running on a polite snack and a firm belief in itself. It is a vast metabolic project, and the ocean must support that project with enough food to keep the machinery going. The whale's weight, then, is not just what it is also a clue to what it costs. This is where water enters the conversation as the great enabler. On land, gravity is in charge in a very immediate and slightly smug way. It asks bones and joints and muscles to justify every kilogram. There is a reason the largest land animals, impressive as they are, operate on a very different scale. In the sea, buoyancy changes the terms of the agreement. Water supports the body, distributes stress differently, and makes it possible for evolution to experiment with dimensions that would be fantastically impractical on land. That is why blue whale weight, once you sit with it, does not merely tell you about the whale, it tells you about the ocean too. It tells you that the sea is not only deep and wide, it is physically permissive. It can carry mass in ways land never could. Still, even if buoyancy helps, the body itself remains an astonishing arrangement of living tissue. This is sometimes forgotten when we toss around neat rounded figures like 150 metric tons or 200 tons. That weight is not inert ballast. It is a heart pumping blood through immense vessels. It is lungs handling colossal breaths. It is muscle powering dives and lunges. It is blubber providing insulation and energy storage. It is bone and baleen and tongue and skin and digestive tract and all the rest of the practical anatomy required to make an animal of this scale exist, without falling apart in a cloud of administrative embarrassment. NOAA's species page emphasises that blue whales are members of the baleen whale family and the largest animals ever to live on Earth. The important thing is not only that they are heavy, it is that they are coherently heavy. Everything has to work. There is also something psychologically different about weight compared with length. Length you can imagine as a line. A school bus is long. A corridor is long. A blue whale is long enough to require effort from the imagination, but still, length is conceptually manageable. Weight is denser. Weight is felt through effort, through resistance, through the body's memory of lifting and carrying and discovering that one bag of groceries was not in fact a clever one-trip decision. So when you hear that a blue whale weighs as much as 15 school buses or up to 30 elephants, the body reacts differently. It does not merely picture space, it pictures burden, load, force. That is one reason the whale becomes more real when its mass enters the conversation. Gravity gives the idea teeth. Of course, the blue whale itself does not move through the sea as though burdened by all this. That is the great visual trick. The whale can weigh more than 330,000 pounds and still appear composed, even elegant. This is one of the ocean's most successful deceptions. Water smooths the drama of mass. A fully grown blue whale does not stomp or creak or produce the kind of visible mechanical strain we associate with very heavy things. It surfaces, exhales, arches, and disappears. To an observer in a boat, the encounter may feel strangely calm for something so colossal. National Geographic Education captures this beautifully in its own practical way, noting that when a blue whale performs an ordinary act necessary for survival, even just breathing or gliding through the ocean, it can be awe-inspiring. That is exactly right. The ordinary actions of an animal this heavy become spectacles simply because the scale is so outsized. Once you let the mass settle into your thinking, a number of everyday assumptions begin to fail rather dramatically. We tend to associate the heaviest things with the most obviously solid, compact, and mechanically stern objects in our world. Locomotives, construction equipment, vast concrete slabs that suggest planners had a difficult week. The blue whale upends that instinct. It is heavy without being compact, heavy without corners, heavy while still being fluid in outline and alive in every part. It is a moving answer to the question of how much living tissue can be gathered into one animal when evolution has enough water, enough time, and enough krill. The result is not a lumbering impossibility. It is an exquisitely functioning giant. And because the exact number is so hard to hold in the imagination, people often assume the most dramatic weight figure is the entire story. But the truth is better than that. The blue whale is not impressive only at its upper extreme. Even the smaller blue whales in northern populations are, as Noah puts it, over 100,000 pounds. Pause there for a second, because that is the quieter version of the same miracle. A blue whale does not need to be the largest Antarctic individual ever sighted to be astonishing. At well over 100,000 pounds, it is already operating on a scale that makes every ordinary mammal comparison feel like something written in the wrong units. The record-breaking giants are spectacular, yes, but even the non-record holders are still very busy being blue whales, which is more than enough. There is another lovely complication hidden in all this, and it is that the whale's weight is not distributed in the dramatic front-loaded way many people first imagine. We are used to large-headed animals or heavily armoured animals looking top-heavy, or at least visually concentrated in some obvious region, but the blue whale's mass extends through a long, streamlined body. Its head is immense, of course, but the rest of the body more than keeps pace. The whole animal is a study in broad-scale volume, not a creature with one oversized feature, and the rest merely trying to cope. This is why weight becomes even more impressive once you start thinking ahead to the individual parts. If the whole animal weighs this much, then the mouth, the tongue, the heart, the blood volume, and the feeding apparatus all begin to take on dimensions that sound at first like exaggerations, and then, after a moment's checking, turn out to be irritatingly real. Weight also brings the blue whale into a broader evolutionary perspective. Noah describes it as the largest animal ever to live on our planet, and Smithsonian Ocean likewise says the blue whale, spanning up to about 100 feet and weighing up to 200 tons, is the largest animal ever to have lived. That means not just larger than modern elephants, larger than modern sharks, larger than other whales, but larger than the famous giants that dominate the public imagination whenever prehistory comes up for air. The blue whale is not merely the winner of the contemporary round. It is the reigning champion across the entire known history of animal size, as usually presented in mainstream zoology and outreach. That is one reason the weight matters so much. It is the number that underwrites the title. Yet for all that grandeur, the blue whale's mass remains part of an ordinary life, if we can use ordinary with suitable caution. It migrates, it feeds, it reproduces, it avoids dangers, it navigates shipping lanes and noise and an ocean altered by human activity. NOAA notes that blue whales today are only a fraction of what they were before modern commercial whaling, and that current major threats include vessel strikes and entanglement in fishing gear. There is something sobering about that. A body of such astonishing weight can still be vulnerable. Being the largest does not make an animal invincible. In some ways, it only makes the stakes clearer. A being this massive, this biologically extravagant, still depends on the fragile particulars of habitat, prey, safe passage, and time. So when someone asks what a blue whale really weighs, the best answer is not just the headline number, though the headline number is already enough to ruin your sense of proportion for the evening. The best answer is that it weighs so much that the usual machinery of imagination needs support. Up to 330,000 pounds, says Noé. As much as 200 tons, says National Geographic Education. About 15 school buses, about 30 elephants, larger Antarctic whales, smaller northern ones, females generally larger than males, and all of them belonging to a species that pushed mammalian body mass into a rangeland could never comfortably host. Those are the facts, but the impression they leave is simpler. A blue whale does not just weigh a lot. It weighs enough to make the whole concept of an animal feel slightly underdefined. And once that mass has settled in the mind properly, the natural next step is almost impossible to resist. Because after the whole body has become heavy in your imagination, you begin to wonder about the individual pieces. Not in a grisly way, thankfully, but in the very human way that follows any enormous machine or creature. How large is the mouth that gathers the food? How much of that weight sits in the tongue, the jaw, the throat, the feeding apparatus itself? Because the blue whale stops being merely very heavy once you start discovering that some of its parts sound large enough to deserve their own separate reputations. Once the weight of a blue whale has settled into the mind, the next place the imagination usually goes is the mouth, because at some point a sensible person begins to wonder how an animal of that size actually gets enough food into itself to remain a blue whale rather than a very large argument against planning. And here the blue whale becomes even stranger in the best possible way. Its mouth is not built like the mouth of a crocodile or a shark, or any of the usual dramatic examples people reach for when they think of powerful jaws. It is built for volume, for filtration, and for turning enormous mouthfuls of seawater into a useful supply of tiny prey. Noah Fisheries describes blue whales as feeding almost exclusively on krill, straining huge volumes of ocean water through baleen plates that hang from the roof of the mouth and work like a sieve. That one sentence already tells you something important. The blue whale's mouth is not mainly a grabbing device, it is a harvesting system. This is one of the first details that makes the animal feel even less like the storybook giant many people carry around in their heads. We are used to a certain logic. If an animal is enormous, then surely its mouth must be full of oversized teeth and bad intentions. But the blue whale has no teeth at all. It belongs to the baleen whales, and baleen is a filter-feeding structure made of keratin, the same general material that makes up our fingernails and hair. Noah's Ocean Today explains that baleen whales have plates hanging down each side of the upper jaw rather than teeth, and those plates are made of fingernail-like keratin. NOAA's Sanctuary Outreach likewise describes baleen as fringed keratin plates used to strain seawater for food. So the largest mouth in this story is not armed like a trap. It is furnished like a very serious filtering tool. That matters, because the blue whale does not chase individual prey item by item. It goes after dense swarms of krill, those small shrimp-like crustaceans that sound far too modest to support the largest animal ever known. NOAA says blue whales swim toward large schools of krill with their mouths open, then close their mouths around the krill while inflating their throat pleats. After that, they push the trapped water back out with the tongue and use the baleen plates to keep the krill inside. In other words, the mouth is not merely large, it is the front end of a whole feeding method in which speed, expansion, filtration, and timing all have to work together. The whale is not nibbling, it is lunging, engulfing, straining, and swallowing on a scale that makes ordinary feeding look like paperwork. And this is where the mouth stops being simply big and starts becoming a piece of anatomical engineering that genuinely suits the ocean. Blue whales are rorquals, a family of baleen whales known for pleated throat grooves that let the lower part of the mouth and throat expand dramatically during feeding. The Marine Mammal Center notes that in blue whales, 55 to 68 throat grooves run from the throat to the navel, and that blue whales have over 800 black baleen plates. A 2024 anatomical paper on rorquals explains that these pleated grooves, present on the underside of the body, allow expansion of the oral cavity during feeding. and can extend as far back as the umbilicus. So when a blue whale opens its mouth on a patch of krill, it is not simply opening a large jaw. It is unfolding a huge expandable pouch built to take in prey-laden water in extraordinary quantity. That expandable design is one of the reasons the mouth feels so perfectly matched to open ocean feeding. On land, you could have a large mouth, certainly, but the full drama of taking in an immense mass of water and prey all at once would be useless, not to mention inconvenient for the carpet. In the ocean, though, water is both the medium and the problem. The prey is suspended in it. The whale must move through it. The food arrives mixed with it. So the mouth has evolved not to separate prey from the world neatly at the point of capture, but to take the whole messy parcel first and sort it out immediately afterward. That is why Noah emphasizes the sequence. Open mouth, engulf water and krill, expand the throat pleats, close the mouth, then force the water back out while the baleen traps the food. It is less like biting and more like running an enormous living net through a cloud of prey. The remarkable part is just how far this expansion can go. The 2024 Rockwell Anatomy paper states that during a lunge, the volume of water engulfed can actually be larger than the volume of the whale itself, and that the tongue inverts and expands backward into a ventral pouch during the process. That is an absurdly useful fact, because it shows that the blue whale's mouth is not merely large compared with ours, or compared with a horse's, or compared with any sensible land mammal. It is functionally capable of turning the front half of the animal into an enormous temporary holding chamber. When people say the blue whale has a mouth built for the ocean, this is what they mean. It is built to take in a colossal rush of seawater, because that is exactly what feeding in the open ocean requires if your prey is tiny and your body is gigantic. Of course, this is not a relaxed activity. It may look smooth from the outside, but the biomechanics are demanding. Research on Rockwell lunge feeding describes the whole event as highly energetic and notes that the complete gape cycle, from opening to closure, lasts only several seconds, with blue whales opening the jaws to a maximum gape of roughly 78 to 80 degrees. The Natural History Museum in London puts it in more public-friendly terms, saying that each feeding lunge is one of the largest single feeding events on Earth, and that the fast movement requires huge amounts of energy. So the blue whale's mouth is not simply a giant bucket drifting politely through soup. It is a high-performance feeding apparatus used in bursts that demand speed, power, coordination, and very good timing. That is part of what makes the mouth feel so ocean-specific. If you tried to imagine the same arrangement on land, it would sound ridiculous. A giant mammal sprinting at a dense patch of airborne food, opening its mouth to nearly 80 degrees, inflating the entire lower face and throat into a huge pouch, and then squeezing out the air while filtering insects through hanging keratin curtains would be the sort of thing natural history museums would have to explain very carefully to worried schoolchildren. But underwater, in a medium that supports the body and carries the prey, the design becomes not only plausible, but astonishingly effective. The Natural History Museum notes that a blue whale can engulf tons of krill in one mouthful and gain more than 100 times the energy needed for the lunge when conditions are right. That is the key point. The mouth is extravagant because the feeding opportunity is extravagant. There is also a quiet elegance to the filtering stage, which is easy to overlook because people understandably get distracted by the mouthful itself. Once the whale has engulfed the prey-laden water, the baleen does the work of retention. Noah describes the baleen as hanging from the roof of the mouth and functioning like a sieve, while the whale pushes water back out with the tongue. The 2024 Rockwell Anatomy paper explains that after engulfment, muscles of the floor of the mouth and the ventral grooved blubber contract, forcing water out through the baleen plates while concentrated prey remains, and can then be swallowed through a relatively narrow esophagus. So the whale is not swallowing a sea full of water and hoping digestion will sort it out. It is actively processing the mouthful, retaining the valuable bits, and discarding the rest with remarkable efficiency. The tongue deserves a moment here, because in most mammals the tongue is introduced as a loyal, mostly uncomplicated organ, helpful in speech, helpful in swallowing, occasionally unhelpful in moments of social embarrassment. In large rorquals, it becomes something far more dramatic. The anatomical paper notes that during lunge feeding the tongue inverts and expands backward into a fascial pouch, helping accommodate the immense volume of engulfed water and prey. That means the tongue is not just sitting there waiting to push some krill around politely. It is part of the dynamic architecture of the mouth. It changes position dramatically during engulfment and then helps drive the water out during filtration, which is all rather unfair to the rest of the mammalian class, whose tongues now look somewhat undercommitted. The pleats themselves also deserve more appreciation than they usually get. People hear throat grooves and imagine a few folds of skin, perhaps a slightly baggy arrangement, the sort of detail that would not normally justify public excitement. But on a blue whale, these ventral grooves are central to the whole feeding system. The Marine Mammal Centre says there are 55 to 68 of them, extending from the throat to the navel, and they expand when the animal takes in water while feeding. Those grooves are not decorative wrinkles. They are structural allowances for one of the most extreme feeding manoeuvres in the animal kingdom. They are what let the blue whale's lower jaw and throat region balloon outward into a huge temporary pouch. Without them, the mouth would still be large. With them, it becomes operationally enormous. This also helps explain why the head of a blue whale feels different from the head of a typical predator. It is broad, long, and shaped not for gripping prey in the dramatic one-by-one style, but for maximizing engulfment and filtration. Noah notes that blue whales have a broad, flat rostrum and a generally slender body, and that baleen plates line the upper mouth while the throat pleats inflate during feeding. Smithsonian Ocean adds another useful detail from field observations. Blue whales may roll dramatically, even close to 360 degrees, as they lunge into krill patches, which can improve how they approach, see, and corral the prey. So the mouth is not acting alone. The whole front portion of the body, along with the whale's motion and orientation, is involved in making the feeding event work. That rolling behaviour is a good reminder that the blue whale's mouth is not just large in a passive sense. It is part of an active hunting strategy. Smithsonian Ocean describes tagged blue whales rolling onto their backs and lunging through krill patches with mouth agape, powered by strong fluke strokes and guided by the position of the pectoral flippers. So when the mouth opens, the whale is not simply drifting forward with optimism. It is making a calculated, energetically expensive move to intersect a dense prey patch in just the right way. The mouth, then, is better thought of as an adjustable intake system in a giant animal, whose feeding success depends on timing and control as much as sheer size. All of this becomes even more impressive when you remember what the mouth is actually for. Not fish the size of dogs, not squid the size of dramatic legends. Krill, small crustaceans, tiny prey gathered in huge numbers. NOAA says blue whales feed almost exclusively on krill, and the Natural History Museum notes that a whale can consume many thousands of individual krill with each gulp. This pairing of the largest animal on Earth, with prey small enough to fit comfortably in the palm of your hand, is one of the most useful correctives to lazy thinking about size. It reminds us that giant mouths do not always belong to giant biters. Sometimes they belong to giant strainers. Sometimes the road to becoming the largest animal ever known is not to develop a bigger tooth, but to perfect a better sieve. There is another small but lovely detail hidden in the anatomy papers and public summaries, and it is that swallowing still has to happen through a relatively small diameter esophagus compared with the vast oral cavity. The 2024 Rorqual paper explains that after filtration, the concentrated prey moves from the oral cavity into the pharynx and through a narrow esophagus to the stomach. That means the huge mouth is not simply a bigger version of a normal mammal mouth, leading to an equally huge throat in every respect. It is more specialized than that. The mouth is gigantic because the job of intake is gigantic. The swallowing pathway is built for concentrated prey, not the full unfiltered mouthful. This is another reason the mouth feels like an ocean tool rather than a general-purpose anatomical excess. Every part of the system is doing a specific task, and because blue whales can make multiple lunges in a single dive, the whole system has to reset quickly. The same anatomical paper notes that successive lunges during one feeding dive can be initiated less than a minute apart, including the time needed for engulfment, filtration, and swallowing. That means the mouth is not only huge and expandable, it is repeatable. It must open wide, inflate the ventral pouch, trap prey, expel water, move the concentrated prey inward, and get ready to do it again, all while the whale remains underwater and manages the energetic cost. This is less like an occasional party trick and more like a demanding industrial cycle, except the industry in question is one whale, and the factory floor is the open ocean. Once you begin to understand the mouth in these terms, the blue whale's overall size starts making more sense. The whale is large partly because its feeding method rewards large scale. Larger mouths can engulf more prey-laden water, and denser prey patches can make those giant lunges worth the enormous energy they cost. That relationship between mouth design, engulfment capacity, and body size is part of why researchers study lunge feeding so closely. Smithsonian Ocean puts the central idea very simply. Blue whales got so big because they are really good at what they do. The mouth is one of the clearest places to see that truth in action. It is not oversized for spectacle. It is oversized because the ocean allows, and the feeding strategy benefits from, a mouth capable of taking in extraordinary amounts of water and tiny prey at once. So when we say a blue whale has a mouth built for the ocean, we are saying something very literal. It has baleen plates made of keratin instead of teeth. It has dozens of pleated grooves that let the throat and lower jaw region expand to a remarkable degree. It has a tongue that can invert backward during engulfment and then help drive water back out. It can lunge at krill patches with its mouth open, sometimes while rolling, and process a huge mouthful in seconds. It can trap tiny prey from immense volumes of seawater, then repeat the whole event again and again during a dive. None of that would make much sense in any other setting. In the ocean, though, it becomes one of the most successful feeding arrangements ever built into a mammal. And once the mouth has come into focus like that, another part of the whale begins to press forward in the imagination almost immediately, because a feeding system this extreme naturally leads to thoughts of the other oversized pieces hidden inside and around it. The tongue alone has already begun to sound like something with its own biography, and that is before we get to the heart, which has managed to become famous in its own right by being so large that people cannot mention it without reaching for the nearest available car. By the time most people reach the heart and the tongue in their imagination, the blue whale has already done enough to make ordinary proportions feel slightly unreliable. It is one thing to accept that an animal can be close to 100 feet long and weigh as much as many tons of machinery. It is another to realize that the parts inside the body scale up in ways that seem almost impolite. The blue whale is not large only as a silhouette. It is large in pieces, in components, in individual anatomical details that each sound as though they ought to belong to separate legends. And yet they all belong to one whale, moving through seawater with the calm of something that has never once had to explain itself. The Royal Ontario Museum describes the blue whale's heart as the largest of any animal on Earth, and its preserved specimen is presented as the first and only real preserved blue whale heart in the world. That alone is enough to make one sit a little more quietly. The heart is where many people start, probably because hearts have such a strong symbolic life in the human imagination. We associate them with courage, panic, romance, grief, overexertion, and regrettable decisions involving stairs. So when we hear that a blue whale has the largest heart on the planet, the mind reaches immediately for a comparison it can hold. Monterey Bay Aquarium uses the familiar phrase that the heart is as large as a small car, while a National Geographic education piece discussing a preserved specimen from the Royal Ontario Museum gives a more grounded estimate of about 5 feet long, 4 feet wide, 5 feet tall, and roughly 400 pounds. That is a useful correction, because small car is vivid but a bit loose. The point is not that the heart is literally identical to some hatchback waiting outside a supermarket. The point is that it is an organ so large that the language of vehicles enters the conversation at all. There is something especially strange about that, because a heart is such an intimate thing in ordinary life. You never see your own. You feel it occasionally, perhaps in your chest after running, perhaps in your throat before saying something difficult, perhaps in your ears at 3 in the morning when you would very much like it to stop reminding you that you are awake. It remains personal, hidden, fist-sized in the usual mental image. Then the blue whale arrives and quietly replaces that picture with a heart weighing around 400 pounds in one preserved specimen, the largest known for any animal, and the scale of mammalian life starts to wobble again. This is not just a larger version of what we carry. It is a circulatory engine working inside a body so extreme that Stanford researchers, after recording a wild blue whale's heart rate for the first time, suggested the heart may already be operating near physiological limits that help explain why no animal has evolved larger. That Stanford study adds another layer to the heart's reputation, because it shows that the organ is not merely large in a static museum sense. It is dynamically remarkable. Stanford reported that in the first wild recordings, the whale's heart rate slowed to about 4 to 8 beats per minute during dives, with a low of 2 beats per minute, then rose to roughly 25 to 37 beats per minute at the surface, while the whale was breathing and restoring oxygen. There is something almost comical about that range, when you remember how anxiously human hearts behave over deadlines, caffeine, and mildly brisk walking. The blue whale's heart slows, surges, and manages a body of astonishing mass while diving, lunging, and resurfacing in the open ocean. It is a reminder that the organ's greatness is not only in bulk, it is in performance. A large heart that could not cope with a large life would simply be oversized furniture. The blue whale's heart is doing real work at the edge of what biology appears willing to permit. Naturally, once the heart becomes famous, the aorta cannot resist joining the conversation. Popular folklore has long enjoyed the image that a person could swim through a blue whale's arteries, a claim so vivid that it has travelled far beyond the caution of the people who first repeated it. National Geographic Education, discussing the preserved heart specimen, specifically pushes back on the most dramatic version of that tale. The Royal Ontario Museum offers a more measured and still very memorable statement. In its blue whale specimen, the aorta is large enough for a human head to fit inside. That is a much better sort of fact, because it is both astonishing and restrained. It does not need to become a theme park attraction to be impressive. If the main blood vessel of an animal is large enough for a human head to fit into, ordinary mammalian scale has already surrendered the argument. One need not crawl anywhere. The point has been made. Then there is the tongue, which may be the most quietly ridiculous part of the entire arrangement. Hearts get attention because they are dramatic and central and culturally overbooked with meaning. Tongues, by contrast, usually lead unglamorous careers. Helpful, certainly. Important, yes. But not often introduced with awe unless someone has just eaten a badly chosen pepper. The blue whale changes that. Monterey Bay Aquarium says the tongue weighs 2 tons, while National Geographic Education uses another memorable comparison, saying it can weigh as much as an elephant. Both versions are doing the same job. They are trying to make the mind accept that a single organ inside a single animal can already belong to the scale of other entire large animals. A tongue like that is not merely a biological detail. It is a logistical event, and yet the whale needs it. Because in a filter feeder of this size, the tongue is not decorative. It is part of the machinery that helps force water back out of the mouth, while keeping krill trapped behind baleen. That functional part matters, because it keeps the tongue from becoming one of those amusing facts people repeat, without understanding what the organ is actually doing. The The blue whale's mouth is not just a giant opening. NOAA explains that once a blue whale closes its mouth on a lunge of krill-rich water, it pushes the trapped water back out with its tongue and uses baleen plates to keep the prey inside. In other words, the tongue is an active participant in an immense filtering process. It is helping move an enormous mass of seawater through a mouth designed not for biting individual prey, but for engulfing and processing huge volumes of ocean. So when one says the tongue weighs about 2 tons, the proper response is not merely surprise at the number. It is recognition that the feeding system of a blue whale requires parts scaled to the job. The organ sounds absurd only until you remember the animal it belongs to, and the oceanic work it has been assigned. The skull is another part that tends to arrive in the mind a moment later than it should, perhaps because people are still busy recovering from the tongue. The Royal Ontario Museum notes that in one of its blue whale specimens, a female about 76.5 feet long, the skull alone is 30 feet, or 9 meters long. That is a useful fact because it prevents the head from remaining a vague front-end concept. 30 feet is not a head in any ordinary sense. 30 feet is a room. 30 feet is a vehicle length. 30 feet is the sort of measurement that should not be paired casually with the words skull alone. And yet there it is. The head of a blue whale has to house that broad rostrum, those baleen-lined jaws, those blowholes, the sensory equipment required for life in open water, and all the structural support needed for lunge feeding. Once again, the animal reminds you that its gigantism is not concentrated in one theatrical feature. It is everywhere. And because the front end is already so outsized, the rest of the feeding apparatus begins to feel almost unfair. The Marine Mammal Centre states that blue whales have over 800 baleen plates and between 55 and 68 throat grooves extending from the throat to the navel. Those details are easy to read past if you're not careful, but they matter enormously. The baleen plates are the filtering structures that let the whale retain krill while expelling water. The throat grooves are the expandable pleats that allow the mouth and ventral pouch to balloon during feeding. Taken together, they turn the front half of the whale into something very close to a biological industrial system, though one should imagine a very graceful one with better hydrodynamics and considerably less paperwork. The blue whale's other enormous parts are not isolated curiosities. They are an integrated feeding design in which skull, tongue, baleen, grooves and muscle all cooperate on a scale that only the ocean really makes possible. This is also why the small car comparison for the heart, useful as it is, can distract from the larger truth. The blue whale is not impressive because one organ can be likened to a vehicle, or because one blood vessel invites unwise metaphors, or because the tongue could stand in as a rough unit of elephant. It is impressive because all these parts belong together inside one functioning mammal. The heart must circulate blood through an immense body. The tongue must help process colossal mouthfuls of water. The skull must anchor a feeding structure built for bulk capture rather than precision biting. The baleen must sort prey from ocean. The throat grooves must expand without tearing, then contract and reset. Stanford's work on heart rate and NOAA's description of feeding behavior both point in the same direction. Every oversized part exists because the whole animal is running an extreme but coherent design. Nothing is large just to be large. It is large because the job demands it. There is something quietly satisfying in that. Human beings often think of size as spectacle first and function second. We imagine giant things as exaggerations, as though nature occasionally loses discipline and starts doodling in the margins. But the blue whale's anatomy is not a doodle. It is a highly tuned answer to a specific ecological opportunity. Krill occur in dense swarms. The open ocean allows huge bodies to move and feed efficiently. Filter feeding rewards immense gulp size. Long migrations favour streamlined forms, and so the parts become giant in ways that still make biological sense. The heart is enormous because the body is enormous. The tongue is enormous because the feeding event is enormous. The skull and mouth structures are enormous, because a whale of this kind survives by processing extraordinary mouthfuls again and again. The pleasure of studying these organs is that they make the logic of gigantism feel concrete rather than mythical. At the same time, the blue whale's anatomy has a way of encouraging bad folklore, usually because the truth is already so impressive that people cannot resist nudging it a little further. The car-sized heart becomes a slightly too literal car. The aorta becomes a tunnel one can supposedly swim through. The whale turns, in retelling, into a creature whose every part must be stretched to the edge of fable, but the restraint of the real measurements is actually more satisfying. A preserved heart around 400 pounds is extraordinary without embellishment. An aorta that fits a human head is extraordinary without inviting tourists. A tongue weighing around 2 tons or as much as an elephant is extraordinary without any further dramatic flourishes. The real blue whale does not need assistance from exaggeration. If anything, exaggeration cheapens the strange dignity of the actual animal, which is already operating so far beyond everyday scale that sober description is more than enough. There is another subtle effect these giant parts have on the imagination. They make the whale seem less like one big animal and more like a community of impossibly large anatomical decisions living under one skin. The heart is famous. The tongue is famous. The skull has its own intimidating credentials. The baleen and grooves turn the whole lower face and throat into a kind of deployable feeding architecture, and all of them coexist inside a body that still has to do very ordinary mammalian things such as breathe, nourish a calf, maintain temperature, and travel vast distances between feeding and breeding grounds. That coexistence is what gives the blue whale so much of its almost unreal quality. You are not merely learning isolated fun facts. You're watching your sense of what a mammal can be stretched piece by piece until it becomes difficult to remember where the usual limits used to sit. And then, just when the mind has grown comfortable with the idea that a single adult blue whale can contain a heart like that, a tongue like that, a skull like that, and a feeding system scaled to the open sea, another thought arrives with exquisite timing. None of these parts appeared all at once. They began in an animal that was born already huge by the standards of almost everything else on Earth, which means the next truly unreasonable part of the story is not the fully grown giant, but the fact that even a newborn blue whale enters the world at a size that would make many adult animals feel quietly underprepared. If the adult blue whale already feels like a violation of comfortable proportions, then the baby blue whale arrives as the final insult to every ordinary sense of scale. There is something almost comical about the phrase, baby blue whale, because the word baby carries such gentle expectations with it. We picture something small, or at least something that can be held or fussed over, or tucked somewhere without requiring an entire coastline to cooperate. But a baby blue whale enters the world already ranking among the largest newborn animals on Earth. National Geographic states that after about a year in its mother's womb, a blue whale calf is born weighing up to 3 tons and measuring about 25 feet long. National Geographic Education gives a closely matching range of about 7 to 8 meters, or 23 to 26 feet at birth. So the first thing to understand is that baby here does not mean tiny. It means already massive, just not finished yet. That is one of the most useful and most unsettling facts about blue whales. The newborn is not merely large for a newborn whale, it is large by the standards of the animal kingdom in general. A calf around 24 or 25 feet long is already longer than many full-grown marine mammals, and longer than most creatures any person will ever stand beside in real life. Monterey Bay Aquarium's educational material describes the newborn blue whale as about 24 feet long, which means the calf begins life at a length many people would associate with a substantial boat, a large room, or a vehicle that definitely should not be attempting a 3-point turn in a narrow street. The mental adjustment required is the same one the blue whale keeps forcing on us again and again. The familiar word remains, but the scale attached to it has become deeply unreasonable. The weight makes it even more difficult to hold in the mind. Up to 3 tons at birth, says National Geographic, not after months of growth. not after a childhood spent diligently becoming more whale. At birth, a calf arrives already weighing more than many adult land animals people would describe with complete confidence as extremely large. The phrase baby blue whale therefore contains a hidden trick. It sounds as though it belongs to the same category as puppy, foal, calf in the farmyard sense, or perhaps a bundled up infant in a picture book. In reality, it refers to a newborn mammal the size of a long vehicle and heavier than many sensible pieces of construction equipment. That mismatch between the softness of the word baby and the force of the numbers is part of why blue whale calves feel almost as unreal as the adults. There is also something rather marvellous in the fact that, despite this immense size, a blue whale calf is still unmistakably a youngster. It still depends entirely on its mother. It still has to learn the rhythms of surfacing and breathing and swimming alongside a body so vast it has spent the whole series quietly humiliating our sense of proportion. NOAA's Blue Whale Recovery Plan notes that weaning likely occurs about 6 to 7 months after birth, while NOAA's Whale Outreach page says that for most large whales, the calf typically remains with its mother for about a year before becoming independent. Those two timelines are not contradictory so much as they describe different parts of dependence. Milk feeding may end around the first half year or so, while close association with the mother continues longer. So even though the calf is enormous from the start, it is still very much a calf, nourished, guided and protected by its mother through the earliest months of life. And that early dependence has a practical side that is every bit as extraordinary as the size itself, because growing from already huge toward future living mountain requires an astonishing amount of fuel. National Geographic says a blue whale calf gains about 200 pounds every day for its first year. NOAA's Whale Outreach page gives a nearly identical public figure, saying a blue whale calf may gain almost 200 pounds per day. Monterey Bay Aquarium's educational card offers another vivid detail, saying the newborn drinks around 130 gallons of milk a day and can double its weight in 1 week. Now, one should always treat the most dramatic educational comparisons with a sensible amount of caution, but even taken conservatively, the overall picture is clear. A blue whale calf grows at a rate that makes ordinary mammalian growth seem shy and underambitious. That daily gain is one of the strongest reminders that blue whale life is scaled up from the very beginning. A human baby gaining even a tiny fraction of that amount in a day would cause alarm, paperwork and several anxious phone calls. A blue whale calf gaining close to 200 pounds a day is simply carrying out its biological assignment. This matters because it reframes the calf not as a miniature adult, but as a body in the middle of an enormous, urgent construction project. The newborn is already huge, yes, but the whale is still in one of the most accelerated growth phases in the natural world. The calf does not ease into blue whale life. It arrives and begins expanding with extraordinary determination, powered almost entirely by the richness of its mother's milk. The milk itself deserves a moment, because for an animal growing this fast, milk cannot be the gentle, thin sort of liquid people vaguely imagine from ordinary dairy contexts. NOAA says whale milk is very rich, which helps explain the rapid growth. The International Whaling Commission's Whale Watching Handbook says blue whale calves can gain up to about 90 kilograms per day from drinking their mother's rich milk, and describes whale milk as having the consistency, almost, of cottage cheese, with a fat content around 30 to 40%. That is an excellent corrective to any lingering image of a calf simply sipping politely as if at a seaside cafe. This is concentrated fuel for one of the most ambitious infancy schedules ever attempted by a mammal. There is also the simple emotional oddity of imagining a calf this large still being vulnerable. Adults, once they reach full size, have relatively few natural predators, but NOAA's recovery plan notes that young or ailing blue whales are more vulnerable, and specifically says calves are most vulnerable to attacks by killer whales, and possibly sharks in some regions. That is a useful reminder that gigantic newborn does not mean invulnerable newborn. The calf may already be enormous by our standards, but in the ecology of the open ocean it is still an inexperienced young animal, newly born into a world of migration, breathing, swimming efficiency, maternal coordination, and the quiet dangers of a vast sea. Scale can impress us, but life still judges creatures by fitness, timing, and survival, rather than by whether they sound good in a comparison chart. Another part of the calf story that often goes unnoticed is how little direct observation we actually have of the moment of birth itself. NOAA's recovery plan says there are no direct observations of the birth of a blue whale calf. That is a striking fact in its own right. We know these animals exist. We know their newborn size. We know they must be born somewhere in warmer waters after a gestation of roughly 10 to 12 months. But the actual birth remains largely hidden from human eyes. That hiddenness adds something to the mental picture. The largest animal on Earth gives birth to one of the largest newborns on Earth, and this event still mostly takes place beyond us, in oceanic spaces where the species conducts its most intimate business with complete indifference to our curiosity. It is all rather dignified, really. And yet, even without witnessing the birth, the dimensions alone tell a great deal. A calf, 23 to 26 feet long, is not just an impressive baby. It is a calf already long enough to make many adult whales of smaller species look less secure in their reputations. It also means that blue whale mothers are managing a newborn of extraordinary dimensions almost immediately. Imagine trying to guide, nurse, and coordinate movement with a youngster already the length of a substantial boat. This is one of the many places where the blue whale quietly forces the mind to widen its idea of parental care. Maternal behaviour is not only about tenderness in the abstract. In this case, it is also about manoeuvring life at a scale that makes the entire phrase mother and calf feel bigger, heavier, and more physically impressive than usual. The calf's early life also helps explain something important about blue whale evolution. An animal this large cannot begin life too small and simply hope for the best. The ocean is expansive, the travel distances are long, the mother's milk is rich but finite, and the body plan itself belongs to a lineage that already commits heavily to size. Starting big gives the calf a kind of immediate momentum. It is born into the world not as a delicate afterthought, but as a serious young marine mammal already equipped with the dimensions needed to keep growing in a demanding environment. That does not make life easy, but it does make the strategy clear. Blue whale infancy is not about daintiness. It is about scale from the first breath onward. There is something especially interesting in the way this alters our emotional response to the word calf. In many species, the young trigger a kind of instinctive softness because they are conspicuously small, awkward, or unfinished. Blue whale calves certainly are unfinished. They still have much growing to do. They are still dependent. But they are unfinished in a way that resembles an enormous architectural project already occupying most of the lot. They do not look unfinished because they are tiny. They look unfinished because, astonishingly, there is still more to become. That is a very different sensation. The blue whale calf is not a small beginning. It is a giant beginning. And there is something humbling in realizing how much growth remains even after the newborn has already reached a scale that would qualify as spectacular in almost any other context. It also helps to place the calf alongside the adult in the mind, because that comparison reveals how unusual blue whale development really is. The adult may reach around 100 feet and up to 200 tons in widely used public-facing estimates. The calf may begin around 24 or 25 feet and up to 3 tons. That means the newborn is already occupying a substantial fraction of the adult's length, even if it is much less than a mature animal in mass. We tend to think of babies as tiny fractions of their adult form, but blue whales do not indulge us in that expectation. Their calves arrive at a scale that already commands respect, then add mass and refinement with extraordinary speed in the months and years that follow. The pattern is the same one we have been seeing throughout. Blue whales do not do ordinary proportions even in infancy, and because the calf grows so quickly, the mother's role becomes even more impressive. Producing that milk, supporting that growth, and moving with the calf through breeding and migratory waters is no minor biological footnote. Noah's recovery plan notes that calf production depends partly on the mother's ability to replenish food stores depleted during lactation, and that the average calving interval is often 2 to 3 years. That tells you something important about the energetic cost of raising a blue whale calf. This is not an annually casual undertaking. A mother invests heavily, and the rhythm of reproduction reflects that investment. A baby blue whale is large because its beginning is expensive, and expensive because the body it is becoming belongs to the largest animal known to have lived. The phrase baby blue whale also does something else rather useful. It exposes how much of our understanding of animal size depends on language habits. Baby suggests small. Calf suggests something that might wobble around a field. Blue whale suggests huge. Put them together and the brain hesitates, because two familiar categories have collided and are now making contradictory demands. That hesitation is worth preserving. It keeps the animal from collapsing into cliché. A baby blue whale should sound slightly unbelievable, because the reality behind the phrase is slightly unbelievable, at least until the measurements force the issue. 23 to 26 feet, up to 3 tons, up to roughly 200 pounds of gain a day, months of nursing, a year or so of close maternal dependence. Those are not romantic exaggerations. They are the practical opening terms of life for the largest animal on Earth. And still, despite all that, the calf remains deeply whale-like in the tender living sense. It surfaces to breathe. It stays close to its mother. It is part of a pair moving through warm waters, then eventually on through the larger cycles of the species. National Geographic Education describes a mother nudging her calf to the surface to breathe, which is one of those details that brings the scale back into emotional focus. No matter how large the newborn is by our standards, it is still a youngster being guided through the first necessities of life. This is one of the blue whale's loveliest contradictions. The newborn is huge enough to disrupt ordinary categories, but still young enough to belong unmistakably to the universal story of mammalian care. Perhaps that is why the blue whale calf stays with people once they hear about it properly. It carries both comfort and astonishment at once. Comfort, because it is still recognisably a mother and young story. Astonishment, because everything in that story has been scaled up until the measurements sound as though they were written by someone who had lost contact with moderation. The calf begins life, already longer than many rooms, already heavier than many adult animals, and then starts growing at a pace that turns milk into geometry. If the adult blue whale makes the imagination stretch, the calf makes it stretch in a different direction. It reminds us that enormity is not only an end state. For this species, it is a starting condition. And once that starting condition has settled into place, another practical question begins to loom, because it is one thing to know how large adults and calves can be on paper, and another to understand how scientists manage to measure animals like this at all, when they spend most of their lives moving through open water, surfacing only in parts, and generally refusing to line up neatly beside anything with a ruler. There is something faintly unfair about trying to measure a blue whale at all, because the animal seems almost designed to frustrate the neat habits of scientists and the hopeful instincts of anyone holding a ruler. A blue whale is not a museum object laid out obligingly on a clean floor. It is a living body moving through open water, surfacing briefly, arching, diving, changing angle, vanishing under glare, reappearing in pieces, and generally reminding everyone involved that the sea does not run on laboratory manners. And yet, if we want to understand how big blue whales really are, how they grow, how healthy they are, and how different populations compare over time, then someone has to find a way to measure a giant that rarely stays still and almost never offers its full outline all at once. That challenge is exactly why whale measurement has become such an interesting blend of patience, practical engineering, careful statistics, and the sort of field work that depends heavily on weather behaving itself for once. For a long time, the simplest answer to how do you measure a whale was, unfortunately, after it is dead. Woods hole. Oceanographic Institution notes that because of their size and aquatic life, the only way researchers historically obtained body mass data for whales was by weighing dead or stranded individuals, and WHOI adds that much of the older size data came from whaling operations, accidental fisheries bycatch, or beach strandings. That approach provided important information, but it also came with obvious problems. A dead whale is not a living whale. It cannot be followed through time, it cannot show seasonal changes in condition, and once a carcass is stranded it may be distorted by bloating or deflation, which WHOI explicitly notes as a source of inaccuracy. So the earliest measurements gave science a foothold, but they did not solve the deeper problem of understanding a whale as an active, changing, free-living animal. That is an important distinction, because size in a living blue whale is not just a static number. Researchers want to know growth, body condition, reproductive status, and how all of those change with food supply, migration, stress, and environment. NOAA Fisheries says researchers now use drones to capture high-resolution images of whales, a process called photogrammetry, to analyse body size and shape and determine body condition, related to factors such as age, sex, food availability, or reproductive status. A recent open access workflow paper goes further and says drone-based photogrammetry has become the primary method for estimating body condition in living cetaceans and comparing changes within and across seasons and among populations. So measuring a whale is no longer only about settling an argument over how long it is about reading the body as evidence of how well that whale is managing the demands of life at sea. The basic idea behind modern photogrammetry is wonderfully straightforward, even if the execution is not. You take an overhead image of the whale, make sure you know the scale of that image, and then convert measurements in pixels into measurements in meters. NOAAs. West Coast Science page describes photogrammetry simply as making quantitative measurements from photographs and notes, that researchers use it to obtain data on length, growth, and body condition. The 2025 workflow paper explains the same thing more technically, saying that each aerial image has a ground sampling distance, meaning the real-world size represented by each pixel, and that once this scale is known, pixel measurements of the animal can be converted into actual body lengths and widths. It sounds almost comforting at that level, as though the whale has become a tidy image problem. Then the sea, the light, and the whale's own opinions enter the story. The drone itself is only the beginning. NOAA says some whale researchers fly a small hexacopter 100 to 200 feet above whales to take overhead photographs, using those images to monitor growth, assess body condition, and identify pregnancies. That overhead angle matters because it gives the cleanest view of the whale's outline, but even then the image is only useful if the whale is in the right position. The 2025 workflow paper says measurement errors can be introduced by glare, wave refraction, the whale's pose, the whale's depth below the surface, analyst variability, and systematic errors from the drone system itself. It specifically notes that the best images are those with the animal in a straight body position, at or just below the surface, with minimal interference from waves and glare. In other words, science would ideally like the whale to lie flat under a clear pane of glass in perfect lighting. The ocean, perhaps unreasonably, refuses to provide this service. This is one reason drone flights often involve collecting many images or video frames, rather than trusting a single lucky shot. The workflow paper notes that video can be useful because it creates more opportunities to select a frame in which the animal is straight and minimally distorted by the environment. NOAA's Alaska newsletter describing drone-based baleen whale measurement says researchers position the drone about 130 feet above a surfacing whale and ideally record it when the body is flat on the surface, stretched out, and fully visible, with all contours clear. The same source explains that drone altitude and camera focal length are used to scale the image, converting body length measured in pixels into actual length in meters, and that widths can then be taken at 5% intervals along the body to estimate body proportions and body volume. That is the sort of sentence that looks dry on paper and becomes rather thrilling once you remember it is describing a way to measure a living giant that keeps disappearing beneath the sea. Altitude turns out to be especially important. The workflow paper explains that ground sampling distance depends on altitude, focal length, sensor width, and image width, and notes that because focal length and sensor dimensions are fixed, accurate altitude readings are crucial for setting the scale correctly. It also states that altitude contributes the greatest measurement error in many drone systems. That is why researchers care so much about the altimeter on the drone. The same paper says LiDAR altimeters, which measure altitude using reflected laser pulses, provide much greater accuracy than barometric readings. A 2017 Frontier study on aerial photogrammetry of whales similarly described a UAV system with an independent LiDAR/GPS logger and reported mean LiDAR accuracy of 99.9% in tests over water. So when scientists say they measured a whale from the air, they do not mean someone simply guessed the height of the drone and hoped for the best. A surprising amount of the method depends on knowing exactly how high a small machine was hovering over a large wet mammal in moving water. Blue whales, being blue whales, added their own special difficulties. A 2016 study on blue whales measured in Chile using an unmanned hexacopter reported that repeated estimates of blue whale length and width could be obtained with high precision within centimetres, and that such data could be used to monitor growth and body condition over time. That sounds beautifully clean, but it hides a great deal of field effort. Blue whales are long, often only partly visible, and usually appear in conditions less cooperative than a studio portrait. They surface, breathe, and may only offer a brief window in which the entire visible outline is suitable for measurement. The point is not merely that drone methods work, it is that researchers have managed to make them work on one of the most inconveniently large, mobile and ocean-dependent animals on Earth. There is another complication that the ocean introduces, and it is almost philosophical in its stubbornness. Measuring a whale is not just about seeing the whale. It is about seeing the whale as a measurable object rather than as a moving, flexing three-dimensional body, partly refracted by water and partly reshaped by its own motion. The workflow paper notes that an arched body position can bias measurements compared with a straight one, and that the whale's position in the water column matters too. Even if the body is just below the surface, refraction can change apparent dimensions, add chop, reflections, cloud shadows, and the whale's unhelpful habit of being alive, and suddenly the task begins to resemble trying to measure a moving hallway through rippled glass while the hallway occasionally bends. That is why the paper emphasizes filtering for high-quality images and explicitly accounting for uncertainty rather than pretending every picture is equally trustworthy. That last point matters more than it may seem. Good whale measurement is not only about getting an answer, it is about knowing how uncertain that answer is. The workflow paper says Bayesian statistical approaches are now used to model uncertainty in drone-based measurements, and can produce posterior distributions for the length of unknown-sized animals using calibration data from objects of known size. It also notes that those methods have been extended to body condition metrics, growth curves, and even probabilistic classification of maturity and pregnancy. That may sound rather more mathematical than sleepy, but there is something deeply reassuring in it. Scientists are not standing on a boat declaring, "That looks like 23 meters, give or take a mood." They are building methods that carry their own caution, which is exactly what one wants when measuring creatures whose size already tempts the imagination toward overconfidence. There is also a particularly elegant method developed specifically for blue whales from boats, which is useful because drones are not always the only or easiest option. A 2022 study in mammalian biology described a photogrammetric technique that estimated total blue whale length from sequential photographs taken from a boat. Researchers measured the exposed flank from the blowhole to the dorsal fin, while also measuring the perpendicular distance between the whale and the camera to scale the images. They then use known body proportions, largely derived from historical whaling data, to predict total length from that measured section. The study reported that the method's precision generally fell in the 2 to 3% range, that comparisons with aerial photogrammetry showed the approach was unbiased, and that when applied to 169 individuals in the Gulf of California, from 2006 to 2015, it found an average length of 20.49 metres, with a range from 7.45 to 29.01 metres. There is something very satisfying about that. Even if a whale never offers you its entire body in one perfectly scaled frame, science can still stitch together a reliable answer from the parts it does offer. That boat-based method also reveals something quietly important about modern whale science. It does not always discard older data. Sometimes it combines them. In this case, modern photographs of living blue whales were linked to body proportion information derived largely from whaling-era data to estimate total length. That is one of the odd moral and scientific textures of marine biology. Some of the knowledge that now helps protect whales comes from periods when whales were being killed in devastating numbers. WHO's Summary of Modern Body Mass work makes a similar point when it notes that historical data on whale size were often limited to whaling operations, bycatch and strandings. The scientific task now is to extract what can be learned from those records, while replacing destructive measurement with non-invasive approaches. The whale, one hopes, would have preferred we began with the drones, and then there is the broader promise of all this measurement. A whale size is not only a number for field guides, or a source of delighted comparison with buses and basketball courts. Size tells stories about nutrition, stress, growth and reproduction. WHOI says that being able to estimate the body mass of free-living whales opens new avenues for understanding growth and energy requirements, and that weight measurements at sea can help reveal how chronic stresses affect survival and reproduction. SNOAE says drone-based measurements can help assess body condition and even identify pregnancies. The 2025 workflow paper says photogrammetry can be used to estimate age structure, generate growth curves, document changes in mature body length over generations, and compare body condition across seasons and populations. In other words, measuring a giant in motion is not just an act of curiosity. It is a way of asking whether a population is thriving, struggling, shrinking, recovering, reproducing, or quietly telling us that something in its world has gone wrong. That is also why automation has become such a growing interest. The 2025 workflow paper says the field still needs clear, standardized methods so measurements are comparable within and across studies, and it emphasizes open source tools for data collection, post-processing, and uncertainty analysis. It notes that if drone-related errors are not accounted for, they can bias both individual and population-level analyses. This means measuring whales is no longer just about taking a photo. It is also about software, calibration objects, camera distortion, image selection, and making sure that one research team's estimate means the same thing as another's. The giant in motion is still the whale, but increasingly the challenge also lies in motion on the scientific side. Technologies changing, workflows improving, methods becoming more standardized, and researchers trying to keep all of that aligned over long time scales. There is a very human charm in that struggle. For centuries, a blue whale at sea was the sort of creature one described in broad, slightly breathless terms. Very long, very large, impressively beyond reasonable fish. Now, researchers can hover a drone over a surfacing whale, account for altitude, correct lens distortion, choose frames in which the body is straight, calculate width at regular intervals, estimate volume, infer condition, and compare one individual across years. We have not made the whale less wondrous by doing this. If anything, we have made the wonder more disciplined. The animal has remained the same astonishing animal. We have simply become better at meeting it with tools that can keep up for a few moments before the sea folds shut again. And still, all the precision in the world does not entirely remove the original difficulty. A blue whale remains hard to feel properly in the mind even after you know the methods. One reason is that measurement gives you scale but not always intuition. Aerial photogrammetry can tell you the whale is 24 metres. It can estimate body condition. It can place the animal on a growth curve. But the emotional force of that length still often arrives later when someone compares it to streets, buses, basketball courts, elephants, or rooms. Science provides the reliable number. The imagination still has to learn how to inhabit it. That is why measuring a blue whale is only half the work. The other half is translating the result into a world the human body understands. And once the scientists have done their part and pinned the whale down in meters, pixels and uncertainty ranges, the next irresistible step is ours. We want to compare. We want to know how this giant stacks up against the dinosaurs that usually dominate every conversation about animal size, against elephants that seem enormous until a blue whale enters the room, and against the objects of everyday life that can finally make all these carefully measured numbers hit home with proper force. By this point, the blue whale has probably already done what it always does to the mind. It has taken words we thought we understood, such as long, heavy, large, and calf, and made them feel underprepared for the job. So it helps to bring the whale down into comparisons we actually live with. Not because the whale needs ordinary objects to validate it, but because our imaginations do. And the first useful correction is this. When museums and science organisations say, the blue whale is the largest animal known to have ever existed, they are not being casual. Noé says blue whales can reach about 100 feet in length, with Antarctic individuals up to about 110 feet, and more than 330,000 pounds. Smithsonian Ocean likewise describes the blue whale as the largest animal known to have ever existed, reaching about 100 feet or roughly 30 metres. American Museum of Natural History says the same thing even more bluntly. The blue whale is the biggest animal ever known to have existed, bigger than the enormous dinosaurs. That is not just largest whale, it is the top of the known animal scale, full stop. Still, largest ever can sound grand without feeling especially physical, so let us begin with length in everyday terms. NOAA's outreach page says a blue whale can grow to 31 metres or 100 feet, roughly the length of a basketball court. That comparison is useful because a basketball court belongs to the human world of floors, painted lines, and visible edges. You can stand at one end, look to the other, and feel the distance in your body. Now replace that floor with one living mammal. Not a string-like mammal, not some thin ribbon of whale, but a deep-bodied, warm-blooded, air-breathing animal. That is when the number starts to become less like trivia and more like a spatial event. If you prefer a school bus version of the same thought, Delaware's school bus standards cap overall bus length at 40 feet. So, a 100-foot blue whale is not one bus, and not two, but two full 40-foot school buses placed nose to tail with about 20 feet of whale still left over, which is an unreasonably large amount of leftover whale by any civilized standard. Weight makes the comparison sharper still, because gravity is less forgiving than length. NOAA says Antarctic blue whales can weigh more than 330,000 pounds. Britannica says the African bush elephant, the largest living land animal, weighs about 9,900 to 13,500 pounds, with some males reaching up to 24,000 pounds. That means a top-end Antarctic blue whale outweighs roughly 25 to 33 typical African bush elephants, and even if you compare it with the very largest bulls Britannica mentions, you still need more than a dozen of them to match one whale. That is one of those calculations that quietly rearranges the furniture in the mind. Elephants already feel enormous, they look enormous, they sound enormous, they have the decency to take up a landscape properly. And yet, next to a blue whale, even elephants begin to feel like the land's respectable, but ultimately smaller answer to a much more extravagant oceanic idea. The same thing happens if you use cars instead. Britannica says the average car weighs about 4,100 pounds. Set that beside NOAA's more than 330,000 pound figure for a very large Antarctic blue whale, and you get a body mass equal to about 80 average cars. 80. Not parked neatly in a lot, not spread across a motorway in some apocalyptic insurance dispute, but somehow gathered into one animal with lungs, a tongue, a heart, a feeding cycle, and a social life carried out mostly below the surface of the sea. This is why blue whale comparisons can sound silly at first and then suddenly stop being silly. They begin as mental aids and end as reality checks. The whale is not merely bigger than the average things around us. It is bigger by amounts that make everyday objects look like weak units of measure. Once those ordinary world comparisons land, the dinosaur question arrives exactly on schedule, because human beings simply cannot leave the dinosaurs out of any conversation involving scale. And to be fair, they have earned the attention. The important thing, though, is to separate length from mass. Some giant sauropod dinosaurs appear to have rivaled or exceeded blue whales in length, at least on some estimates. The Natural History Museum in London lists Argentinosaurus at about 35 metres and 70 tonnes, while also stressing that it is known from fragmentary remains and that calculating its size, especially its body mass, is tricky. The same NHM overview lists Sauroposeidon at 27 to 34 metres and 40 to 60 tonnes, Tyrannosaurus at 30 to 39 metres and 51 tonnes, and Dreadnoughtus at 26 metres, with older estimates around 59 tonnes but later body volume estimates scaled down to about 22 tonnes, with other estimates in between. So if you ask, could some dinosaurs have been as long as or longer than a blue whale? The careful answer is yes, possibly, depending on which dinosaur and which estimate you use. But if you ask, could they match the blue whale in mass? The answer becomes much less generous to the dinosaurs. That is where the blue whale reasserts itself with great calm. NOAA's blue whale page gives the upper figure as more than £330,000 for Antarctic animals, and NOAA's outreach material gives the familiar public figure of up to 160 tonnes for blue whales at about 100 feet. Smithsonian Ocean says they can weigh up to 200 tonnes. Put those side by side with NHM's sauropod estimates, and the pattern becomes clear. Argentinosaurus at around 70 tonnes is astonishing for a land animal, but it is still far below the blue whale's upper-end mass. Sauroposeidon at 40 to 60 tonnes, Tyrannosaurus at 51 tonnes, and the more disputed Dreadnoughtus estimates are lower still, so the fairest way to say it is this. A few giant dinosaurs may have rivaled or beaten blue whales in length on some reconstructions, but by weight the blue whale remains in a class of its own, among animals known to science. That is why museums and major science organisations keep calling it the largest animal ever known, not merely the longest or the most famous. There is something pleasingly humbling about that outcome. The public imagination often gives dinosaurs permanent first place in every size contest, simply because they arrived first in childhood books and have spent decades posing dramatically in museum halls. Dinosaurs also enjoy an advantage in mood. They look ancient, heavy, and self-important. Blue whales, by contrast, live in water and often present themselves as smooth backs, distant blows, and brief glimpses of impossible scale before sinking again. So the mind tends to give the dinosaurs more visual authority. But when you bring in the numbers carefully, the balance shifts. NHM's own dinosaur size page repeatedly emphasises uncertainty around the very biggest sauropods, because many are known from incomplete remains. Blue whales, meanwhile, are measured from real bodies, real sightings, real strandings, real drone surveys, and real populations still alive today. So there is a lovely reversal in it. The creature that can feel more unreal at first turns out to be the one whose size is more securely anchored in observation. Elephants remain useful because they show the difference between land bigness and ocean bigness in a way dinosaurs cannot. Britannica says the African bush elephant stands up to 13.1 feet at the shoulder and weighs about 9,900 to 13,500 pounds, with some males higher. That is already an extraordinary animal. An elephant is so large that it changes your sense of personal scale simply by standing nearby. It is not a creature you can misunderstand physically. But the blue whale takes that feeling and expands it far beyond land's comfort zone. In rough terms, a 100-foot blue whale is more than 7 times the shoulder height of a very tall African bush elephant. And in mass, as we have already seen, one big Antarctic blue whale can outweigh dozens of typical elephants. The land's champion is still working under gravity's stricter rules. The whale, supported by seawater, is playing a different game with much larger pieces. Everyday life offers another set of useful corrections because it reminds us that the blue whale is not merely big compared with the other animals. It is big compared with the architecture of ordinary existence. Noah's basketball court comparison is one of the best because most people can feel it immediately, but even shorter comparisons help. A 100-foot body is longer than many houses are wide. It is longer than the sorts of vehicles we think of as large. Using Delaware's 40-foot school bus limit, you can say the whale is 2.5 bus lengths, and that already feels mildly outrageous. Using Britannica's average car figure, you can say the mass approaches 80 average cars, and now the mind starts to see parking lots. This is the real service of everyday comparisons. They pull the whale out of the abstract oceanic distance where everything tends to look smaller than it is, and put it back into the scale of rooms, roads, and things with corners. Even the smaller members of the giant animal club begin to look different once a blue whale has entered the frame properly. NOAA's outreach page says fin whales, the second largest whales, can reach up to 88 feet and weigh up to 76 tons. Humpback whales, which people often experience as astonishingly large on whale-watching trips, reach about 60 feet and 40 tons on the same NOAA page. Grey whales get to about 49 feet on Smithsonian Ocean Size Chart. None of those figures are remotely modest. A 60-foot humpback is still the sort of animal that can leave a boat full of adults whispering like schoolchildren in a cathedral. And yet, in the company of the blue whale, even these giants become scale markers. The blue whale does not merely edge them out. It changes the mood of the comparison. Once the largest whale appears, the others start to look like large whales. In a world where one animal decided large was only the opening bid, there is also a psychological trap in all these comparisons, and it is worth noticing because it explains why people can hear the numbers many times without fully absorbing them. Comparisons help, but they also risk turning the whale into a string of tidy analogies. Basketball court, buses, cars, elephants, dinosaurs. Useful, yes, but only to a point. The danger is that the whale becomes a parade of examples rather than a living animal. The real force of the blue whale is that all those comparisons belong to one body at once. It is basketball court long and elephant defeatingly heavy. It is bigger by mass than the famous giant dinosaurs we most often reconstruct with confidence. It is longer than many human-built spaces feel emotionally ready to host. And still it breathes, feeds on krill, migrates, nurses calves, and disappears below the surface as if none of this required special comment. That is the moment the comparisons stop being party facts and start becoming perspective. Perhaps the best way to hold it in the mind is not to ask which single comparison wins, but to let several sit there together. A creature about the length of a basketball court, a body mass greater than 330,000 pounds, the largest living land animal multiplied many times over, sauropod dinosaurs that may challenge it in length, but not convincingly in mass. A giant so large that the American Museum of Natural History simply says it is bigger than the enormous dinosaurs, and no one really objects because by the broadest, most public-facing measure, that is the truth. The blue whale is what happens when mammalian life in the ocean finds a way to turn abundance, buoyancy, and time into an answer larger than almost anything the land or the fossil record can comfortably counter with. And once those comparisons have done their work, another thought begins to push through almost on its own. If this animal is longer than so many human spaces, heavier than so many human-made objects, and beyond even the great land giants in mass, then the real question is no longer just how we compare it to familiar things. It becomes how the ocean itself can support something so vast in the first place, and why water, unlike land, seems willing to let life make that kind of offer to size. After comparing the blue whale with buses, elephants, and the larger names from prehistory, the next question becomes less about the whale itself and more about the world that makes such a creature possible. Because that is really the heart of it. A blue whale is not just a large body, it is a large body that works. It feeds, dives, travels, reproduces, and carries on for decades in an environment that somehow supports all that mass without collapsing into absurdity. At first, the answer seems easy. The ocean can carry something so vast because water holds it up. That is true, and it matters a great deal. NOAA notes that cetaceans are specially adapted to the buoyant support of water, and stranded whales do badly in part because their hearts, lungs, and other organs are not accustomed to their own weight outside that support. Smithsonian Ocean also notes that whale blubber is less dense than seawater, which adds buoyancy and helps them float. So the first and most obvious part of the answer is that the sea spreads and supports weight in a way land never could. That simple fact changes almost everything. On land, gravity insists that size must pay for itself with bones, joints and legs that can bear the full downward force of the body at all times. In the water, the body is supported on all sides. The whale still has mass, of course. The whale still has inertia, drag, and the practical problem of moving a great deal of tissue from one place to another, but it is not crushing itself under its own weight in the way a land mammal of similar mass would. NOAA's guidance on stranded cetaceans makes this plain in a rather sobering way. Outside the buoyant support of water, the organs of whales are under stresses they are not built to handle. So when people say the ocean carries the blue whale, that is not a poetic way of speaking. It is a literal biomechanical truth. Remove the water, and the whole design stops making sense very quickly. But that is only the beginning, because water does not merely support enormous mammals. It also makes life harder for them in another way. Water pulls heat from a warm body much faster than air does. This is one reason marine mammals do not simply shrink down into neat, efficient little versions of themselves. A 2018 PNAS study found that the aquatic realm actually imposes stronger constraints on mammal body size than life on land, driving and confining aquatic mammals to larger sizes. Smithsonian Ocean says larger whale species retain heat better because their skin surface area is small compared with the size of their bodies, and it notes that blubber also helps them survive in deep or freezing polar water. So the ocean can carry something vast partly because, for a warm-blooded mammal, vastness is not just allowed, it is often helpful. Large bodies lose heat more slowly relative to their volume, which makes life in cold water much easier than it would be for a smaller mammal trying the same trick. That point is worth pausing over, because it corrects a very common misunderstanding. People often assume marine mammals are big simply because water frees them from gravity and lets them indulge in size. The 2018 PNAS work suggests something more interesting. Aquatic mammals need to be big, but not too big. Stanford's summary of that research said the range of viable body sizes for mammals in the ocean is actually smaller than the range on land, not larger. In other words, the ocean is not a place of unlimited physical freedom. It pushes mammals away from very small sizes because of heat loss, but it also does not let them grow without limit. The sea is generous with support, but strict with energy. The blue whale exists where those two pressures meet in a very unusual and very successful way. That is where food enters the story, and once food enters the story, the blue whale begins to make more practical sense. According to NOAA, blue whales feed almost exclusively on krill, straining huge volumes of ocean water through baleen, and some of the biggest individuals may eat up to 6 tons of krill a day. Nowhere also says blue whale distribution is driven largely by food availability, and that they occur where krill are concentrated. So the ocean can carry something this vast not only by holding its body up, but by producing food in dense enough patches to make such a body worth maintaining. A giant mammal cannot survive on scenic views and marine optimism. It needs an environment that can offer staggeringly rich feeding opportunities, and the open ocean, at the right times and in the right places, does exactly that. This is one reason baleen whales, and especially blue whales, were able to become so much larger than toothed whales. A 2019 science study summarised the pattern neatly. Whale gigantism is driven by the interplay of prey abundance and harvesting mechanisms that increase prey, capture rates and energy intake. Stanford's 2018 news summary likewise noted that baleen whales can grow larger than toothed whales, because filter feeding expends much less energy on feeding and allows them to take advantage of abundant prey. That matters enormously. A giant predator chasing individual large prey runs into one set of limits. A giant filter feeder sweeping huge numbers of small prey from dense swarms runs into a very different set. The blue whale's mouth, baleen, pleats, and whole feeding style are what turn ocean productivity into whale size. The ocean is carrying the whale physically, yes, but it is also carrying the whale economically. The timing of whale gigantism adds another useful layer. Smithsonian Ocean explains that researchers have suggested marine gigantism accelerated during the onset of the Pleistocene, roughly 2.5 million years ago, when a particularly productive ocean, and possibly a patchier distribution of food, may have favoured larger bodies. That same Smithsonian account notes the idea that a large body would help whales push through the water more effectively and store more energy when food sources were far apart. So the ocean did not merely provide more food in a simple, evenly spread way. It may have become a place where food was rich but patchy, rewarding animals that could travel efficiently between profitable feeding zones and store enough energy to survive the gaps. In that world, being large was not just impressive, it was useful. That efficiency in travel is another piece people often miss. Smithsonian Ocean notes that whales have streamlined bodies that help efficient swimming, with flukes providing propulsion and flippers mainly used for steering. It also says streamlined bodies reduce the amount of oxygen needed during diving. A large animal does not help itself much if all that size makes movement ruinously expensive. The blue whale solves that problem with a body shape built for water rather than against it. This is why a blue whale can look so calm while covering long distances. The shape, the support of water, and the mechanics of swimming all work together. The ocean can carry something so vast because the animal has been built to move through that medium with far more efficiency than any land giant of equal mass ever could hope for. Breathing and oxygen storage matter as well, because a body this large cannot bob up every few moments like an indecisive cork. Smithsonian Ocean states that the blue whale can hold the equivalent of 1,300 gallons of air, and that whales absorb over 80% of the oxygen in a breath, compared with only 15 to 20% in humans. The same source notes that whales have high levels of oxygen-storing molecules, and that their heart rates slow during dives. These features do not directly explain why the whale got big in the first place, but they do explain how a body of that size remains workable in the sea. A giant animal needs giant support systems, and the blue whale's respiratory and circulatory adaptations mean that the ocean is not only carrying the body from outside, the whale is also extremely good at managing the internal business of being enormous underwater. There is also a seasonal rhythm to this whole arrangement. Noah says blue whales generally spend summers feeding in polar waters and then undertake lengthy migrations toward lower latitudes as winter arrives. That pattern makes sense once you remember where the food is richest and when. Productive feeding grounds allow the whale to take in extraordinary amounts of energy, and a large body helps store and transport that energy across long distances. Smithsonian Ocean's discussion of modern ocean patchiness fits this nicely. If food is concentrated in certain times and places, then a very large whale can take advantage of those peaks and survive the travel between them. The ocean can carry something so vast because it offers both the physical medium and the seasonal feast and travel pattern that rewards large, efficient migrants. And yet, for all its generosity, the ocean is not offering blue whales an unlimited blank check. The same 2019 science study that explained whale gigantism also explained why whales are big but not bigger. Its summary says gigantism is limited by prey availability and foraging efficiency. That is a deeply useful point because it keeps us from imagining the ocean as a place where size can increase forever. Every extra ton has to be paid for, every feeding lunge costs energy and oxygen, every migration has a budget. The blue whale sits near the upper edge of what the ocean can support for a filter-feeding mammal because the physics of engulfment, the density of prey patches, and the returns on each lunge eventually stop improving fast enough to reward further size. The ocean can carry something so vast, but not anything whatsoever, it still keeps books. That limit is one of the most interesting parts of the story, because it makes the blue whale feel less like an accident and more like a balance point. The 2018 PNAS work on aquatic mammal size argued that heat loss pushes marine mammals toward larger bodies, while energy intake sets upper bounds. Stanford's summary of that same work described ocean size as a narrower viable range than land, not a wider one. Then the 2019 science work showed how baleen whales can reach exceptional sizes because their prey and feeding mechanics make very large bodies profitable up to a point. Put those ideas together, and the blue whale begins to look like the result of several separate pressures all agreeing, briefly and magnificently, on one answer. Water support, heat retention, oxygen management, filter feeding, patchy prey, long migrations and energy storage all line up well enough to make a giant feasible. There is a slightly humbling lesson in that. We tend to look at the blue whale and see excess. Too large, too heavy, too much of everything. But the ocean does not reward excess for its own sake. It rewards designs that work. Smithsonian Ocean notes that blubber also acts as an energy store when food is scarce. And NOAA says blue whales occur where krill are concentrated and may consume up to 6 tons a day. The body is vast, not because nature became theatrical, but because a body of this scale can insulate itself, store energy, travel efficiently, and harvest enough dense prey to justify the cost. The whale looks extravagant to us because our daily lives are lived at a much smaller scale. To the ocean, under the right ecological conditions, the blue whale is not a fantasy. It is a practical giant. Seen that way, the title question changes a little. The ocean can carry something so vast because carrying turns out to mean several things at once. It means buoyant support for a body that would fail on land. It means a cold environment that rewards large size and blubber. It means a food web capable of producing immense swarms of krill. It means migration routes between rich feeding grounds and breeding areas. It means a medium where streamlined forms can travel with great efficiency. And it means physiological systems, from oxygen uptake to diving response, that make underwater life at giant scale possible. Remove any one of those pieces and the blue whale becomes harder to explain. Keep them together, and the largest animal known begins to look less like an impossibility and more like an answer. The sea arrived at very slowly and very convincingly, and once that answer starts to feel solid, there is a curious calm in it, because the blue whale no longer seems merely oversized. It seems fitted to its world in a way that is both grand and strangely sensible. The ocean does not just tolerate the blue whale. Under the right conditions, it makes the blue whale possible. Which leaves us with one final turn of the thought, because after all the numbers, the anatomy, the measurements, the comparisons and the mechanics, what lingers most is not only how large the whale is, but why the existence of something that large can feel oddly comforting once you have sat with it long enough. And so, after spending this much time with the blue whale, something rather interesting tends to happen. The animal stops feeling like a record and starts feeling like a presence. At the beginning, it is easy to treat it as a set of astonishing measurements. About 100 feet long, or even longer in the largest Antarctic individuals. More than 330,000 pounds at the upper end. A heart that has become famous in its own right. A tongue so heavy it can be compared to an elephant. A newborn calf already around 23 to 26 feet long and weighing up to 3 tons. a body fed by dense swarms of krill and sustained by an ocean that can support a scale land simply cannot. Those are the facts, and they are extraordinary facts. NOAA, Smithsonian Ocean, National Geographic, and other major science sources all agree on the broad picture. The blue whale is the largest animal known to have lived. But facts by themselves are not always what stay with us. Numbers can impress us in the moment and then slide away. We nod, we think, goodness, that is large, and then we move on to smaller concerns like emails, washing up tomorrow morning, the thing we forgot to do 3 days ago and only remembered while brushing our teeth. The strange part is that the blue whale resists being forgotten so neatly. It tends to linger in the mind, not just because it is big, but because it is big in a way that makes the world feel different afterward. Once you have sat with the scale of it properly, the ocean no longer seems like empty distance between coasts. It starts to feel inhabited in a more serious way. Somewhere out there, beyond roads and rooftops and all the familiar measurements of daily life, an animal of this size can still rise to breathe and then slip under again. There is something comforting in that, and it may not be obvious at first why. Human beings are not always calmed by large things. Storms are large. Problems can feel large. Bills have a way of becoming emotionally larger than the paper they are printed on. Bigness, in everyday life, often means inconvenience, risk, or a queue, moving much more slowly than one had hoped. But the blue whale does not feel that way. It feels large without feeling urgent. It feels immense without feeling aggressive. It is one of the biggest things life has ever produced, and yet the image most people carry of it is not one of chaos. It is of calm movement, a back rising, a blow in the cold air, a long dark body slipping forward, a tail lifting, and then the sea closing over it again. That kind of size lands differently. It does not crowd you. It does not insist on itself in the way cities do or machinery does, or even in the way certain personalities do when they enter a room and begin treating conversation as a competitive sport. The blue whale is enormous and quiet about it. Perhaps that's part of the comfort. It reminds us that greatness does not always arrive noisily. The largest animal on Earth does not need a dramatic soundtrack. It does not need armour, teeth displayed for effect, or a permanent expression of fury. It moves, feeds, breathes, and continues with the business of being itself. There is something deeply steadying in that kind of scale paired with that kind of restraint. It also helps that the blue whale is not large in a meaningless way. It is not a random giant. By the time we reach this point, we know that its size belongs to a whole system. The ocean supports its body. Its blubber helps retain heat. Its baleen and expandable mouth let it harvest huge numbers of tiny prey. Dense krill patches make its feeding strategy worthwhile. Migration and body design work together. The giant heart and the giant tongue and the giant body all make sense once you understand the environment that shaped them. That is comforting too in its own way. The whale is not an accident floating through the sea. It is a fit. A vast, elegant fit between body and world. There is a relief in seeing something so large that still belongs. Much of modern life can feel oddly mismatched. Too much noise for too little meaning. Too much speed for too little satisfaction. Too much information and not enough room to think. The blue whale offers the opposite sensation. It is one of the clearest examples in nature of scale with purpose. Every part of it, however outsized it may seem to us, answers to something real. Cold water, buoyancy, prey density, migration, energy, survival. The result is not clutter, it is coherence. A body built on a scale that seems almost unreasonable from the outside and completely sensible once you understand the ocean's terms. That sense of coherence can feel unexpectedly soothing. It suggests that not everything large is out of control. Not everything beyond our ordinary scale is chaos. Some things are simply better understood when we stop trying to force them into human-sized logic. The blue whale is too large for casual intuition, but not too large for explanation. In fact, One of the pleasures of learning about it is feeling the explanation catch up to the astonishment. First comes the surprise, then comes the structure behind the surprise, and somewhere between the two, wonder becomes calmer. It settles in. There is also a quieter kind of comfort in the whale's indifference to us. That may sound cold, but it is not. Human life can become very crowded with ourselves. Our schedules, our opinions, our endless little emergencies, our fond belief that the whole world should ideally arrange itself around parking, reception, and whether the internet is behaving. Then along comes the blue whale, not literally in front of us, but in thought, and suddenly the proportions shift. This animal does not care about our clocks. It does not know what an inbox is. It is not remotely interested in most of the things that keep people awake. It belongs to older rhythms and larger distances. It feeds where the food is dense. It migrates when the seasons turn. It surfaces to breathe. It dives again. And in remembering that such a creature exists, some of our own concerns begin to look smaller, in a way that feels healthy rather than dismissive. That may be the deepest comfort of all. Not that the blue whale solves anything for us, because it does not. It does not pay bills, mend relationships, or make tomorrow less complicated. But it does offer perspective, and perspective is sometimes the gentlest thing available. A body 100 feet long, moving underwater in the dark, sustained by swarms of tiny crustaceans and by the cold, immense machinery of the sea, has a way of rearranging the emotional scale of the evening. You do not necessarily feel that your problems vanish. You simply feel that the world is wider than them, and there is dignity in that wideness. We have spent this entire journey making the blue whale understandable through comparisons. Buses, basketball courts, elephants, cars, large dinosaurs, houses, rooms, whole lines of practical everyday things dragged in one by one to help the imagination keep up. Those comparisons are useful. They do important work. But in the end, they are still only bridges. The whale itself remains more than the objects we use to explain it. It is not a basketball court made of biology. It is not several buses with a heartbeat. It is not 30 elephants with better hydrodynamics. It is a whale. A real one. A species with its own history, its own migrations, its own calf beside its mother, its own need for quiet water and abundant krill, and safe passage through a world increasingly crowded by human noise and shipping and entanglement risk. That reality matters. It keeps the whale from becoming a novelty. It returns it to life, and life, perhaps, is what makes it so moving. Not bigness alone, but living bigness. A blue whale is not a monument. It is not a mountain, not a building, not a machine, not some carved thing meant only to stand there and be admired. It is alive. It was born, improbably huge even then. It grew. It learned to travel, to feed, to surface, and dive in the right rhythms. It may cross vast stretches of ocean with a confidence no map can quite convey. Its body may bear the marks of time, scars, shifts in condition, signs of seasons good or poor. It is not an object at the edge of life. It is one of life's boldest ongoing decisions. That can be strangely reassuring in a time when so many stories about the natural world feel like stories of reduction. Less ice, less habitat, less abundance, fewer animals, more noise, more pressure, more loss. Those stories are real, and they matter. Blue whales themselves were hunted to catastrophic lows during the era of industrial whaling, and their populations are still only a fraction of what they once were, with modern threats including vessel strikes and entanglement. But the blue whale's existence, even under those pressures, is still a reminder that the world has not entirely given up its largest forms of wonder. There are still beings on Earth so large that the mind needs repeated help to picture them properly. There are still realities bigger than our habits of attention. There is comfort in that survival, not because it excuses the damage done, but because it means the story is not only loss. The blue whale is still here, not in the millions it should have had, not free from danger, not outside the reach of our mistakes, but here, somewhere tonight, while people are making tea, folding laundry, scrolling far too long, arguing about directions, or trying unsuccessfully to remember why they came into the kitchen, a blue whale may be moving through dark water under stars or cloud or moonless sky. It may be rising, breathing and sinking again. The fact that such a life continues is not small comfort. It is enormous comfort, if one lets it be. Perhaps that is why so many people find whales calming in the first place. Not just blue whales, though they are the grandest example, but whales in general. They move at a scale and a pace that seem to come from outside our usual forms of agitation. Even when they are active, feeding, migrating, diving, there is often a sense of deliberate motion rather than frantic motion. They remind us that movement need not be panic, that breath can matter, that returning to the surface, taking what is needed, and going under again can be enough for now. The blue whale takes that feeling and magnifies it to the edge of the imaginable. It is calm made vast. And maybe that is why the closing thought here does not need to be dramatic. The blue whale has already done all the dramatic work simply by existing. What remains is quieter. A kind of gratitude, perhaps, that the world still contains things this large and this real. Gratitude that science has given us ways to measure them, understand them, and protect them more carefully than before. Gratitude that our imagination can still be stretched without being broken. Gratitude that not everything meaningful comes in the scale of the human day. If you have followed this long, gentle trail from first impression to length, weight, mouth, heart, tongue, calf, measurement, comparison, and finally the ocean itself, then you're now carrying the blue whale a little differently than when we began. Not literally, of course. No one wants that paperwork, but mentally perhaps. The animal may feel less like a fact from childhood and more like a reality with shape, mass and presence. A body that can be measured, yes, but not reduced. A life that can be studied, yet still leave room for awe. That is a nice place to end up with any creature, but especially with this one. And so, wherever you happen to be listening from, whether you are near the sea or nowhere near it, whether it is deep in the night or merely the quiet edge of evening, the blue whale can remain for a moment as company in the mind. Not company in the cheerful, chatty sense, more in the sense of perspective held nearby. A reminder that the planet is still larger, stranger, and more physically impressive than our routines allow us to remember. A reminder that there are forms of life so vast that they soften the ego simply by being accurately described. A reminder that something can be huge and still peaceful, immense and still graceful, difficult to imagine and yet entirely real. That may be enough. Sometimes enough is exactly what helps the mind loosen. Not an answer to everything, not a final moral polished and presented like a souvenir spoon. Just the steady fact of a blue whale in the world, carried by cold water, breathing air, following food, raising calves, surviving history, and turning size itself into something less like intimidation and more like reassurance. The world is not small. Life is not finished surprising us. And somewhere in the long dark water, something very large is still moving. Sleep well, wherever you are,